to Aeva Day. My name is Andrew Fung, and I lead investor relations and corporate development here at Aeva. It's great to see so many familiar faces, as well as many new ones here in the audience. And to those on the live webcast, thank you for taking the time to join us virtually. So this is our first Investor Day in a few years, and we're really excited to share more about everything that has been going on since then. As you can see on the screen, we have an extensive series of presentations, fireside panels, as well as panel discussions where we'll dive deeper into Aeva's breakthrough FMCW technology platform and how it is shaping the future of perception across a broad range of applications. You hear directly from Aeva's leadership team, as well as many of our key customers and industry partners on what's driving Aeva's exciting commercial momentum. You also learn more about our manufacturing plans to support our bold vision for going beyond the beam to enable a new era of automation for the physical world. After the market close, we will conclude today with a financial update, including Q2 results, and then Q&A with our leadership team. And for those attending in person, we will host a reception at the venue directly after that. So before we begin, I would like to remind everyone that during today's event, we'll be making forward-looking statements based on current expectations and assumptions, which are subject to risks and uncertainties that could cause actual results to differ materially from expectations. These statements reflect our views only as of today and should not be relied upon as representative of our views as of any subsequent date. Please see our most recently filed Form 10-K and Form 10-Q for a discussion of risk factors as it relates to forward-looking statements. In addition, during today's event, we'll be discussing non-GAAP financial measures, which we believe are useful as supplemental measures of Aeva's performance. These non-GAAP measures should be considered in addition to and not as a substitute for or in isolation from GAAP results. We refer you to the reconciliation tables to the most directly comparable GAAP financial measures contained in today's presentation. And with that, let me turn it over to Soroush, Aeva's co-founder and CEO.
Thanks, Andrew, and welcome to Aeva Day. We really appreciate everyone joining us here today in New York City. It's great to see so many of our major customers, our partners, here with us today. I also want to thank our investors joining us here today, and also all of you watching online. Today's theme is Beyond the Beam. Over the course of today, we plan to share more about how Aeva's unique technology platform can bring perception to so much more than what you think is possible with LiDAR. So let me kick off with a bit more about Aeva and why we are uniquely positioned to do that. We started Aeva 8 years ago with a simple but ambitious vision that a new sensing technology could enable perception for everything. And by doing so, it would have the potential to completely transform multiple industries. Now, I'm sure you're familiar with using LiDAR for autonomous driving, but we see LiDAR is no longer only about self-driving vehicles. Imagine making all high-volume manufacturing fully automated in a cost-effective way, or ensuring safety and security of our infrastructure, to making robots and consumer devices smarter and more automated. These are just some of the possibilities that we envisioned when we first started Aeva. Now, we believe the number and the size of our opportunities that are ahead of us are massive and to only grow from here. This is driven by the race to automate the physical world with new levels of perception and AI. To realize Aeva's vision, we built a new technology platform from silicon up, based on FMCW, or frequency modulated continuous wave, enabling breakthrough capabilities, broad adaptability, and scalable manufacturing. This was no easy task. We set out to build a world-class team, starting in Silicon Valley and growing to over 300 experts globally. From silicon and photonics to hardware, software, manufacturing, and business operations, our team brings deep expertise from top tech, automotive, and consumer companies to help bring our technology to the market. We have invested hundreds of millions in R&D, developed multiple product generations, and partnered with customers to meet the toughest real-world requirements across automotive, automation, and infrastructure. Now, looking back, it's incredible to see how far we have come. Since starting the company in 2017, where we began with a bulky, fiber-based proof of concept, which demonstrated our breakthrough, simultaneous range and velocity measurement. Through continuous innovation and miniaturization, we launched Atlas, our first automotive-grade 4D LiDAR built for scale across automotive, trucking, and industrial markets. Now, with the newly announced Eve 1D and 1V, we have extended our platform to precision sensing for manufacturing automation, offering micron-level range and velocity sensing in a small form factor. From lab prototypes to production-ready systems, Aeva is delivering chip-scale sensing solutions for mass adoption. The result of our investment is a unified perception platform, combining our LiDAR on chip, custom processing SoC, and software to deliver breakthrough capabilities across applications. Our chip-based design enables a scalable, cost-effective solution that has not been possible until today. Today, we are gaining strong traction in key verticals where Aeva's differentiated performance and our adaptable perception platform stands out. For example, in automotive, that means enabling automation across broader operating design domains, such as highway speed, automated driving, across passenger, trucking, and mobility. Now, OEMs are consistently telling us that Aeva's long-range, direct velocity sensing, and interference immunity are critical to unlocking these new capabilities, both safely and at scale. In manufacturing automation, where we're seeing rapid adoption since recently entering the market, we're bringing micro-level precision and vibration sensing to areas where Aeva is uniquely positioned to expand. I will be getting more into that later. Thanks to our adaptable software, we're deploying the same core platform to meet entirely different needs, from factory automation to real-time quality control on the high-volume production lines. And in smart infrastructure and transport, our plug-and-play solutions help improve security, traffic flow, and safety in environments like airports, rail systems, and on the roadways. These verticals represent our initial focus, where we have already gained some significant traction. And they all benefit from the same scalable software-defined perception platform that really sets Aeva apart. But we're just getting started. Beyond our initial focus areas, we see strong potential in large and emerging markets like defense, robotics, consumer devices, where we see LiDAR playing a crucial role in the race to automate everything. We are already working with industry leaders who see Aeva's core perception platform as key to enabling this shift. And with our new strategic partner, LG Innotek, we are in an even stronger position to scale into some of these markets faster. Each of these verticals I just spoke about is a multi-billion-dollar market opportunity on its own. Together, we believe they represent a total market opportunity of $80 billion. While we obviously do not expect to capture all of the market, we see immense opportunity for Aeva across these markets. And as Sarat will discuss later in his section, we do believe that Aeva has a significant revenue potential across these verticals. This is a testament not only to our technology, but Aeva's approach to our customers and partners as well. Our focus as a company is to align with leaders in their fields who share our vision for large-scale commercialization and bring the market expertise to really make it real. Aeva is well on its way to leading the adoption of FMCW across multiple verticals, with strong traction in automotive, manufacturing automation, and smart infrastructure. We are proud to be working with some of the biggest names in each of these industries. In automotive, we have a production win and a program with Daimler Truck and Torc, one of the world's largest commercial vehicle OEMs, deploying multiple 4D LiDARs per vehicle. We're also in development with a top 10 global passenger OEM for their global production platform. And today, we're really excited that we have announced a new collaboration with Bendix, the North American leader in ADAS for commercial vehicles. In manufacturing automation, our strategic customers include SICK, LMI, and Nikon, companies with broad reach and hundreds of thousands of units deployed annually. And in smart infrastructure and transport, customers like Sotereon, Sensus Gatso, and Airbus are using Aeva to enable next-generation security and safety solutions. We have already started shipping in automotive, including fleet deployments, and we are seeing commercial rollouts in manufacturing automation and infrastructure. We expect larger scale production programs to begin later next year. Now, at the start of this year, we set out a goal to build an automated production line with over 100,000 units annual capacity. With our growing commercial traction and supported by our customers, for example, Daimler Truck's investment, we are planning to double our production capacity to 200,000 units annually. So, in short, Aeva is uniquely positioned to lead the next wave of perception at scale. Our unified perception platform is designed from the ground up and is powered by proprietary IP, which are central to our approach. This delivers unmatched adaptability across applications within a truly scalable chip-based architecture. Aeva is also drawing industry top leaders. As I mentioned, we have secured major production customers across each of our key initial verticals. And we are on track for more production wins across those verticals, as well as new ones in the months ahead. With strategic partner LG Innotek, we are accelerating our manufacturing as well as our commercialization to expand into new markets. Throughout the day, we'll be diving deeper into each of these topics with our team, our customers, our partners that we are honored that are joining us here today, including Daimler Truck, Torc, Bendix, and Mercedes-Benz in automotive, LMI and Nikon in automation, LG Innotek, as well as our manufacturing partners, Tower Semi and Jabil. It is an exciting time for us and the industry. Perception for everything is here, and Aeva is leading the way. With that, I'm going to hand it over to my co-founder and CTO to dive deeper into the technology. We'll see you later. Thank you.
Thank you, Sarush, and thank you all for joining us today. My name is Mina Rezk, and I'm the CTO for Aeva Technologies. I'm happy to tell you more about Aeva's technology and give you insight on how Aeva is redefining the future of perception. At Aeva, we did not start with an incremental improvements to a legacy time-of-flight system. We started with the first principles. We chose FMCW, Frequency Modulated Continuous Wave, as the foundation of our 4D perception platform. This architecture offers a fundamentally different set of capabilities simultaneous range and velocity measurement, ultra-high precision down to micron level, and the ability to operate over ultra-long distances. Also, we're immune to optical interference, blooming, ghosting, even in the harshest environment. And more importantly, it is all on a silicon photonics platform that is scalable. It is the chip scale integration that makes it possible and capable to expand in markets that was not possible with legacy 3D systems. It isn't just a technical distinction. It is a generational one. It is like the shift from analog to digital, the move from black and white camera to a color camera, or simply it was the shift from a time flight radar to a FMCW radar that happened in the automotive market. The ability to measure and differentiate distance is one of the areas that Aeva technology really, really shines. Aeva technology can operate in multiple range modes, simply by software and changing how the laser gets modulated. In the near field mode, we can detect microns, 1/100th of a human hair. And in the mid-range mode, we still maintain a millimeter precision and centimeter precision in the long and ultra-long range. There is no other LiDAR architecture that can deliver such kind of precision across a wide range modes. Why does it matter? Because real-world environments demand it. From manufacturing inspection requiring micron-level precision, to robotics requiring millimeter precision, to automotive, where detecting a moving object 500 meters away can make the difference between safety and a failure. To give you an idea about such micron-level precision, here is an example demonstration of our technology and its ability to capture micro movements, including something as subtle as a person's pulse pressure or a heartbeat from a distance. What you're seeing here is not a wearable device, no cameras. It's the power of our technology sensing vibrations at a micron level in real time. This opens up a brand new set of capabilities and applications such as in-cabin health monitoring, contactless biometrics right in your home. These are use cases that are only possible with Aeva, and it opens a new category of applications for us. Now, how did we achieve this? It came down to a vertically integrated set of building blocks that we developed in-house. We start with our laser semiconductor lasers, where we designed the laser to allow for the critical laser modulation and maintaining that modulation across different environments. More importantly, we designed this laser structure to be fundamentally proven and based on a fundamentally proven structure from the telecom industry, where they ship millions of these. We also designed our own optical amplifier, where we enabled state-of-the-art high power capable of sensing objects 500 meters away. We then added our own custom ASICs, both for driving lasers and detector amplification, tuned specifically for our technology and FMCW. Then we brought it all together with our silicon photonics. Frankly, this is where most other LiDAR players struggle, but it is where we shine. We have taken complex photonics components, optical pathways, which usually require fiber and careful alignment, and integrated them on a single chip. This not only shrinks the size of the chip, but increases the yield and unlocks mass manufacturability. There's no fibers, There's no manual alignment, just a solid-state scalable solution. Finally, it is all processed on our X1 SoC, purposely built for Aeva, for optimizing the power, the size, and performance. And most importantly, it is automotive grade. When you look at all these building blocks, you realize this is not just a sensor. It is a perception engine. Just because we own every piece, we are able to optimize the entire system, not just for performance, but for reliability and scale. That is the power of vertical integration. That's how we are building the next generation platform that is powered by our deep IP and ready for mass production. Now, all of these building blocks come together in what we call the unified perception platform. At the heart of it is our core vision, our LiDAR-on-chip module. It is supported by our system-on-chip processor and powered by our perception layer, software layer, all to work together in harmony. What makes this platform unique is that it's very modular. Each layer is tightly coupled, but the overall system is very flexible, which means we can adapt it to meet the needs of very different markets without rebuilding it from scratch. It's a huge advantage for us as we scale across the different markets. This single platform today powers portfolio products, our Atlas, Atlas Ultra, Eve 1D, 1V, and our Orion products. All of these products is purposely built to serve different set of markets. Whether it's automotive, manufacturing automation, or smart infrastructure. What's powerful here is that all share the same core foundation. Same laser structure, same assembly process, same SoC, same photonics integration. That gives us tremendous leverage. We can tailor the product form factor, range, field of view, while keeping the underlying technology platform consistent. And for our customers, this means faster development, reduced costs, and future-proof upgrades. Because improvements we do at the foundation level flow across the entire portfolio of products. That is exactly why we were able to bring Eve 1D and 1V to the market quickly. We leverage the same foundational architecture and manufacturing lines that is proven in the field. Now, we do not just ship sensors. We deliver integrated solutions with adaptive perception software layer on top across different markets. Whether you are in automotive, smart infrastructure, manufacturing automation, or speed enforcement, our AI software stack adapts to the specific needs of every vertical. For example, in automotive, we enable object tracking and free space detection. In smart infrastructure, we apply classification, motion profiling for traffic patterns. In manufacturing, it's all about precision inspection. In speed enforcement, it's about the accuracy of detecting speed of moving vehicles on the road. All built on the same LiDAR foundation, customized through software. Again, what makes this possible is that our software is deeply coupled within our hardware. We designed both together. This means we don't just interpret the data, we shape how we read and capture the data. But we are not stopping here. As we know, the technology has a lot more potential beyond what we just released. We will be releasing more products, entering entirely new markets, from defense, next-gen robotics, consumer products. It won't just be depth sensing. We plan to integrate multiple sensing modalities into a single intelligent devices. And this is one of the reasons why we partnered with LG Innotek, a global leader in electronics, camera, optics, with a proven track record of shipping millions of cutting-edge products into consumer and automotive markets worldwide. Their global manufacturing, scale, quality standards, market access make them the ideal partner to take Aeva's perception platform to millions of devices. We're very proud to partner with LG Innotek. Now, we are not just building technology. We are protecting it strongly. Aeva holds the strongest IP portfolio patent in the FMCW domain. Over 245 patents granted to date, and another 150 pending, covering every layer of our stack: laser design, signal processing, system architecture. This gives us a strong and a competitive edge, but also positions us to lead as the market scales. Now, our technology moat is massive. It is deep and growing. We have invested over $500 million in R&D, not just R&D, in real engineering work. Our team includes some of the best in optics, silicon, system engineers. Over the past 8 years, we have optimized our perception platform across multiple generations and real-world testing, which is very key, able to take the units on a car and get data. All protected by our IP. And we have established a manufacturing line and growing the capacity to support the needs of our growing customers. Aeva is the only company in the world with 4D manufacturing lines already running. This is what gives us this multi-year lead. But we are not stopping at the current generation. We are already in deep development of our next generation platform, one that builds on everything we have learned over the past 8 years. While our current generation brought together integration, production readiness, the next generation will take us to a new level of scale and intelligence, making our platform even smaller, more efficient, and versatile. What you're seeing here, I have it with me, is our next generation. All in one chip, photonics and processor in one module. Optimized for 10x lower power and dramatically smaller form factor. This enables us to push into markets that is even more compact, power-sensitive applications, mobile robotics, industrial arms, consumer devices, and drones. But just like before, it is not a one-off product. It is a platform, a foundational architecture that we see that tailor across multiple use cases while keeping the same core. We are pushing the limits of integration, performance, and power, not just to meet today's need, but to stay ahead of what the industry is going. With that, we will shift gears, and I will hand it off to Jessica, who will walk you through our current platform, and how it's being deployed in the automotive market. Thank you.
Thank you, Mina. Hi, everyone. I'm Jessica Urello, and I lead program execution here at Aeva. I work closely with our internal teams and OEM partners to bring Aeva's technology from concept through to production. As Sarush mentioned, there's a significant market opportunity in automotive across passenger cars, trucking, and mobility. And over the next few minutes, I'll share why Aeva's LiDAR is uniquely positioned for these markets and why OEMs are increasingly turning to this technology as they scale autonomy. So let's start with where the market stands today. 10 years ago, LiDAR was seen as a niche technology, too expensive, too experimental, and not yet ready for production vehicles. Most OEMs opted to rely on camera and radar systems, which were more affordable and familiar, even though they came with limitations. Over my 6 years at Aeva, I've seen this technology evolve from research prototype to production ready. Costs are now competitive with other high-end sensors, and performance has advanced well beyond what cameras and radars can offer, especially in edge cases like poor lighting, complex traffic, or ambiguous objects. LiDAR now delivers the level of precision and reliability needed for modern driver assistance and autonomy. It's no longer an experiment. It's a foundational sensor for the future of automotive safety. So as LiDAR gains traction in production vehicles, most current systems are built on time-of-flight technology. This has been a useful first step for OEMs to begin validating LiDAR in real-world conditions. But now that these systems are being deployed at scale, the limitations of time-of-flight are becoming clear. Through my role at Aeva, I speak regularly with OEMs who are now deploying and testing these systems at scale. Many have come to us after experiencing the real-world shortcomings of time-of-flight. Issues like blooming from retroreflectors, poor performance in direct sunlight, challenges supporting higher speed, higher autonomy use cases. And that's where FMCW comes in. It was designed from the ground up to meet the unique needs of automotive applications. With Aeva's LiDAR, OEMs gain key advantages: real-time velocity measurements for every point in the scene, long-range and high-resolution detection, true immunity to sunlight and sensor interference, and built-in perception capabilities that reduce central processing demands and add an extra layer of redundancy. So much like radar technology, which evolved from time-of-flight to FMCW, we believe LiDAR perception is undergoing the same transformation, with Aeva leading the way. Aeva has released 2 products for automotive deployment, Atlas and Atlas Ultra. These market-ready FMCW LiDAR solutions are specifically designed to meet the demands of automotive markets, trucking, passenger cars, and mobility platforms alike. Atlas, the LiDAR that was selected by Daimler Truck North America, and Atlas Ultra deliver precise velocity measurements with every point, long-range and high-resolution perception, and resilience to interference and blooming. Their on-sensor perception and localization capabilities also reduce system complexity and improve overall reliability. So with these products, Aeva offers OEMs a proven path to integrate the next generation of LiDAR, powering safer, more capable, autonomous vehicles across diverse segments. So let's talk about trucking. When a big truck is fully loaded and driving at highway speeds, it needs a long distance to stop safely, sometimes hundreds of meters. And one of the critical use cases for trucking is being able to detect moving vehicles more than 400 meters away. And not just see them, but also know how fast they're going and in which direction. That's critical for giving trucks more time to react. So this is a video of the point cloud data from Aeva's LiDAR. And you can see how Aeva's LiDAR tracks different road users in real time. Outgoing and incoming vehicles are highlighted in blue, bicyclists in yellow, and pedestrians in green. This isn't just object detection. It's intelligent motion tracking across different object categories. By classifying and tracking each type of road user based on their speed and their trajectory, Aeva provides crucial data to help trucks make safer decisions in dynamic environments, whether it's avoiding a fast approaching car or safely navigating around a cyclist. Another critical trucking use case is detecting stopped cars or traffic jams far ahead on the highway. And in this video, you'll see a clear example. Aeva's sensor identifies a stopped car more than 250 meters away, distinguishing it from the surrounding environment. So while traditional sensors may struggle to separate parked or stalled vehicles from roadside clutter or overpasses, Aeva's LiDAR isolates that static object with precision. This kind of early, reliable detection is essential for highway safety, giving trucks more time to slow down or change lanes before it's too late. Another critical use case is driving directly into harsh lighting conditions, like the setting sun. Where cameras and even some LiDAR systems can go blind, Aeva's LiDAR keeps working. And in this video, you'll see a truck heading straight into the intense sunlight. Despite the glare that would typically overwhelm camera sensors, Aeva's 4D LiDAR continues to detect and track road edges and other objects with clarity and confidence. This is the advantage of Aeva's technology. It's inherently immune to ambient light, making it ideal for real-world conditions, where lighting is unpredictable, but perception cannot fail. So these are just a few of the use cases in autonomous trucking that are addressed by Aeva's LiDAR. So let's talk about how Aeva's LiDAR enables passenger car autonomy. One of the key challenges is being able to detect small objects on the road, like tire or debris. And in this video, you'll see how Aeva's LiDAR detects low reflective tires from beyond 150 meters away, even when they're near road reflectors that often confuse other systems. Because of the absence of blooming, the sensor can clearly discriminate these objects from retroreflectors. It can also determine the object's height, helping the vehicle decide whether to stop, avoid, or safely drive over it. Another key challenge is being able to accurately detect lane markings, especially in low light conditions or near bright retroreflectors. And in this video, you'll see how Aeva's LiDAR avoids blooming, and it clearly picks up lane lines and nearby objects, even in the presence of road reflectors. Where other LiDAR systems can get blinded or produce noisy data, Aeva delivers a clean, reliable view of the road, helping vehicles stay centered and safely in lane. And lastly, being able to navigate complex urban scenarios and tracking close cut-ins is critical for passenger vehicles operating in dense city environments. So in this video, Aeva's LiDAR demonstrates how it quickly identifies close cut-ins and vulnerable road users, even when they're partially occluded. So you can see it tracking many dynamic objects, such as pedestrians, bicyclists, and vehicles simultaneously, delivering reliable perception in the most challenging urban conditions. These are just some of the key performance requirements that Aeva's LiDAR can meet to enable a higher level of autonomy. So we've shown you how Aeva's LiDAR addresses real-world challenges in trucking, passenger cars, and mobility, from long-range small object detection to robust performance in complex urban scenes. And a key enabler behind these capabilities is our on-sensor perception. By embedding core perception functions directly in the sensor, we help OEMs reduce system costs and offload central processing while adding an extra layer of safety. Aeva's LiDAR can classify and track both dynamic and stationary objects. It can detect drivable regions and lane lines and estimate vehicle motion, all from within the sensor itself. This built-in intelligence helps lay the foundation for scalable next-generation automation. So building on this advanced sensor intelligence, Aeva is taking another step to support the wider research and development community by releasing its first ever public 4D LiDAR datasets, captured using our FMCW technology in real-world driving conditions. These include examples of urban and highway driving scenarios made available to the public. And the urban dataset highlights performance in dense city traffic with occlusions, cut-ins, and vulnerable road users, showcasing how per-point velocity improves detection, tracking, and motion prediction. The highway dataset demonstrates long-range, high-resolution perception at speed, enabling early detection of small or stopped objects and accurate separation of fast-moving vehicles. So together, these data sets provide developers with valuable tools to build and validate next-generation perception systems, while illustrating how Aeva's technology performs across real-world automotive use cases. So, with that overview, I'll hand it back to Sarush to kick off our fireside chat. But first, a message from Joanna at our partner, Daimler Truck North America. Thank you.
Hello, everyone. I wish I could be there in person with you all, but I'm excited to be with you virtually to share some words about Aeva. At Daimler Truck, we keep the world moving towards a safer and more efficient future, and that future depends on having the right technology and the right partners. For the past 18 months, we've been working closely with Aeva on their production program. Together, we're integrating their 4D LiDAR technology into our autonomous-ready truck platform. And I'm really pleased to say progress is going strong. We're hitting our joint milestones and have already incorporated their LiDAR technology into our next iteration of trucks based on the 5th generation Freightliner Cascadia. With Aeva's start of production planned for 2026, they're a major contributor and enabler of the market launch for our autonomous trucks in 2027. The ultra-long-range LiDAR technology enables level 4 autonomous driving at highway speeds to detect objects at a far distance and leave sufficient reaction time for the virtual driver. We have full confidence in Aeva. Their state-of-the-art technology, their team, and their ability to deliver at scale have been key to this partnership. We are proud to continue to grow this partnership with Aeva and bring their next generation of autonomous driving technology to life in our autonomous-ready Freightliner Cascadia. And we will do that safely, efficiently, and at scale.
Are we having fun yet? All right, well, thank you. I want to thank our panelists and our partners here joining us for the first segment of the automotive session. I'd like to introduce first Peter von Schmidt, the CEO of Torc Robotics, as well as Mike Tober, the CTO of Commercial Vehicles at Bendix. So maybe I'll first start with a first introduction. If you'd like to give a little bit about your background and what is Torc about, and then we can get into the discussions from there. And then same for you, Mike, on your side. So please go ahead.
Thanks, Arush, for having me here and this wonderful opportunity to speak to all of you. Peter Schmidt, I consider myself a veteran of the trucking industry, so I was 17 years with Daimler Trucks and did some epic things. One thing was developing the engine that propels trucks, Freightliner engines, and that was transformative to the market and the foundation of their dominating market share. Was a strategy, and then thought, what is even more transformational than a wonderful engine? That's autonomy. And then we tried a few things back then, found Torc Robotics as an interesting player in the space, because Torc Robotics was out there also for 17 years, automating big trucks that are driving in mines or for military. And there was an opportunity to acquire a majority stake in the company, supported Torc in growth for about 3 years, and then the founder decided to step down, said, hey Peter, it's getting too big for me. Do you want to take over? I said, yep, I'm not a founder, but I've run really big programs. And now I'm 3 years CEO of Torc Robotics. Again, our core field is self-driving, Class 8 trucks, US, and we are starting with the Cascadia truck. And it's looking promising.
Awesome, thank you. Mike?
Yeah, so Mike Tober, I'm with the Bendix Commercial Vehicle Systems, and first a little bit about Bendix and what we do. Bendix is part of a global group, Knorr-Bremse Commercial Vehicle Systems Division, and globally and then locally through the Bendix organization, we provide primarily air brake systems for commercial vehicles, starting with air charging systems, air treatment systems, all the way to the wheel end hardware, so drum and disc brakes. But over top of that, we have control systems, embedded control systems, starting with our braking technology, so systems like anti-lock braking systems, electronic stability control. And then in the last 10, 15 years or so, we also introduced ADAS, driver assistance systems, up to L2 on top of that brake control system. And our focus really in this market, in the commercial vehicle market, is on the active safety technology and continuing to develop that technology. I didn't think I would get to say I was the most senior member in the industry, because I have been in this commercial industry since I started in about 25 years ago. So I've worked in various technical roles at Bendix and some business leadership roles, and now have responsibility for our CTO organization here in North America.
Awesome. So we have with us two very exciting, both large-scale, leaders in your respective areas. At the same time, these are two very different fields, almost in terms of technology and also the market segments. We have full automation, autonomous trucking. We also have active safety. So maybe Peter, can start with you. Maybe we can start off by talking a little bit about what's the latest with our production program together. We've been working on for some time now, a year and a half, and I'm sure the audience would like to hear a little bit about the latest developments, whatever you'd like to share today.
We are working together since many, many years. I think Aeva more or less from the start.
That's right.
So it's super exciting. And in such a development, you have different phases. You have more or less the R&D phase and then advanced engineering phase, where you really try to find out what does it take, in our case, to remove the safety driver and go fully driverless. And there are some really big challenges, especially when it comes to trucking. For example, that's long-range perception. Because a truck has 30% more braking distance, usually also because the brakes are not that strong and it's more heavy, the maneuverability isn't that good like with cars, and you start trying to find out, is it time of flight or is it frequency modulated, and that's how we started our collaboration. And then about a year ago, we made a decision and a big pivot, and I think that's also different than what some of our competitors do. We decided to go to fully production intent. So from the rubber to the roof, that we go on the target hardware, be it a redundant chassis, be it all sensors, be it the compute, not on x86 server rack anymore, but really automotive grade embedded compute. and did this hard transition about over the last 12 months. And it was now super exciting going through this integration hell, having it behind us and not in front of us. And from now on, every iteration is a fast cycle and is paying into our launch that we are targeting for the year 2027. And it was so exciting, let's say about 4 weeks ago, seeing our truck then doing the full hub-to-hub, fully autonomous. It was still safety driver in there, but it was pulling out of the hub in fully autonomous mode, doing intersections, traffic lights, surface streets, highways, mergers, lane changes, all the complicated stuff, day, night, heavy rain. That was a really pivotal moment out of our Dallas hub that we opened up 3 months ago. Why Dallas? Because our launch lane will be Dallas to Laredo. That's where we will haul freight for our customers. And so opening up the Dallas hub to prove out operations, how to operate autonomous trucks, and then on the same time having this breakthrough that we are now on our final physical hardware, that by the way is on target course, that there were the really big achievements and enabled by Aeva. Thank you for this.
Of course.
More to come. Launch
Absolutely.
27 is still stable, and then scaling quick in 28.
Awesome. And maybe to touch on that, you talk about scaling and launching. Can you talk a little bit about the scalability of Torc and Daimler Truck's platform as you think about, both from manufacturing scalability as well as kind of adaptability across platforms? Obviously, it's no secret Daimler Truck is, one of the leaders in the space with significant, almost 40% market share in North America. Freightliner, 100,000 to 200,000 trucks a year, and for us, why that matters is, obviously significant content per vehicle. Every tens of thousands of trucks means hundreds of thousands of sensors for us. So we have to go ahead, start on the production side later next year to be able to support your demand in the following year. How can you maybe explain or describe a little bit about the flexibility of your approach and how you see the scalability and the importance of that as we go towards SOP?
Yeah. I mean, first of all, the key ingredients to scale is that you have a great product. And if you assume for a moment autonomy in principle is solved, and you see a lot of driverless taxis in San Francisco and many other cities, then it's all about, do you have the unit economics right? So what's the cost of the truck, and what is the cost to operate an autonomous truck? And in the end, customer traction. Both of it looks phenomenal currently. I think we have by far the best unit economics out there, by the way, also enabled. It's great to have a great technology, but also your sensor needs to hit certain price points, and it does, which is great. That enables us to offer a really attractive product to customers who then really buy in. The second thing is you need to develop a product which is pretty flexible, especially with autonomy. And there's this vintage style hub-to-hub driving where you have an airport, and you drive manually to something, then you have a middle mile in autonomy and manual driven at the end. This is not really a product that can scale and that customers really like, because you are breaking end-to-end process into 3 pieces. So it's a nice tech demonstrator, and it might be a good entry, but nothing that can really scale. So we developed our technology right from the beginning that we more or less can drive point to point in 80–90% of all cases. We can drive from an existing customer location, distribution center, to an existing customer warehouse, and doing the full journey. And only in absolute rare cases where the warehouse, I don't know, is middle of New York, we would do this driving obviously in manual, but 90% of the cases. And that's important that you design your product also not too a lane or too narrow, but really broadly, and that we did. And then talk to the customers. And in the end, I think there is no limitations. It's really about now thoroughly preparing a launch. It will be all about, and that's why it's important that it comes also from, that it's fully integrated and not retrofitted. That's a production intent or prototype, and that it comes from factories, because nothing can beat a factory in terms of quality, reliability, and last but not least, scalability on cost.
Of course.
And I think all of this homework we have done, and your sensor fits perfectly in. to this concept, and your team is super collaborative.
Awesome.
Supporting this. Thank you.
Yeah, thank you. Same here. So maybe now we can talk a little bit about, on the other end of the spectrum. So perhaps Mike, we can talk a little bit about, obviously today we announced a collaboration. We're working towards bringing next generation of active safety and especially collision mitigation to commercial vehicles. I think many folks maybe in the audience would not think that LiDAR is even needed for level 2. So what's that about? Can you talk about the importance of that? And maybe we can even first start a little bit about your existing solutions, the scale of which today, and all of that.
Yeah, so our current collision mitigation systems today use our fusion product, as we call it, is the fusion of radar and camera technology. And we've had a lot of success in that product. The adoption rate has been quite high. On a Class 8 commercial vehicle, we're seeing on line haul type applications, we're seeing up to 70% adoption rate. And the fleets in the North American region are really seeing their safety numbers improved, mitigation of on stationary objects and such to prevent collision or mitigate the collisions. But we do see that there are certain scenarios out there, which we call our challenging scenarios, that radar and camera combination still can't address. And that has to do with examples would be low light conditions like at dusk and dawn or even in the nighttime, and then vehicles that are partially in lane or offset in the lane or at specific angles where you're relying on a camera learning technology that has to be able to identify all of these various situations, and in some cases it won't detect that, at least in time, to provide a significant mitigation of that scenario. And with the 4D LiDAR technology giving us, at a good range, the right identification of that object so that we can confidently apply brakes on that object, that's a huge advantage that we see to potentially bring this product into our market space. I would say, you have to keep in mind, but we're always trading off the decision to brake this vehicle. It's an 80,000-pound vehicle, and if once you decide you need to brake that vehicle, you're going with this very high deceleration, almost as much braking as that vehicle is designed to provide. And so we have to balance that, making that decision early enough that we can mitigate the collision, but also not so early or with a lack of confidence that we'll apply brakes in a situation where we didn't need to, and that can cause other follow-on effects. So again, the 4D LiDAR technology is really what we see as potentially filling that gap on some of those challenging scenarios.
Makes a lot of sense. I think maybe we can touch on a little bit about the size of the market here for ADAS and the commercial vehicle space and collision mitigation. Maybe you can help quantify that. We were talking earlier. Understand, you guys, Bendix has close to 1 million units for ADAS functionality, collision mitigation already on the roads. Right. So how do you see the penetration? How do you see the size of the opportunity? And maybe you can talk a little bit about, to the extent that you can, sure, kind of where you see the key kind of focus of the market and the audience.
Yeah, so when you look at the air brake commercial vehicle market, which is where we operate, typical builds for that whole market are around 400,000 vehicles a year, some higher, some lower. We're currently in a little bit of a downturn in this market, so it's lower than that. And within that market, you have your line haul, tractor, trailer, semi-trailers that you see out on the highway, but you also have a significant portion of those vehicles that operate in more of the vocational segments, for example, concrete mixers and refuse and such like that. So our primary market for collision mitigation systems is on that line haul segment, which is generally in the order of Class 8's about 300,000 vehicles or so, and then of that 300,000, maybe 200 to 230 or so would be your line haul application. And then of that, like I said earlier, about 70%, we see adoption rate of these technologies.
Yep. So Bendix has a majority market share in ADAS collision mitigation systems. Daimler Truck and Torc have significant market share in obviously Class 8 trucks and for the autonomous space in North America. So obviously from our side, we're really excited to be working on one common product, as we talked earlier about it, with our unified perception platform that allows us to reduce the cost in a way that is making it economically scalable, that we think is uniquely possible with 4D technology, so that it can apply to these very different end markets in a way that is both very long range with high velocity information, high resolution velocity information for fully autonomous, but also for more ADAS applications. So one of the things that I think I want to talk about, and this I think trend will come up, is how do you see kind of future integration of these solutions? Especially we can maybe first touch on the ADAS side. When you look at the multimodality approach, right? So you talk about your existing solutions today utilize camera and radar. So from our perspective, the advantage of 4D LiDAR is provides you that high resolution distance information, but also has that Doppler velocity information. So do you see a world and opportunity, not to put you maybe a little bit on the spot here, but for combining some of these modalities and maybe even replacing some? And where do you see that potential for our collaboration in putting the perception inside at the edge, and how the integration may look like?
Yeah, I see. That there's opportunity there. We want to take a stepwise approach to this. First, see how the LiDAR can really augment our existing fusion systems with the camera and radar technology. But as with any technologies like this, there's always a constant market pressure to really look at the cost-optimized installed solution for that. And I think we definitely see an opportunity here to rethink for that L2 application. Do we really need all three modalities, or can we get down to two?
Yep.
And offer, like I said, a better total cost of ownership to our fleets.
Sounds good. Maybe I think, Peter, we can chat a little bit about as we go towards production. There's obviously significant effort that has already behind us around qualification. Talked about a fully production intent stack that differentiates your approach from others. Can you touch a little bit more on that in terms of there are others in the space that are looking at different approaches around using hardwares that may be in-house developed or hardware that is developed with other multiple stacks of different partners. Where do you see that in terms of any advantages that may have for you in this kind of more partnership approach rather than in-house development approach? Do you have any view on that you can share with the audience around development as it comes around how you separate what's in-house and what's outsourced or partnered?
I mean, that might be the blessing of also being not too early in the game. Because if you were too early in the game, you had to develop a lot of things yourself. Let's say some of the early adopters were building LiDARs themselves in-house, or buying companies are maybe not too happy then afterwards because it's hard to scale. And it's also a lot of effort and investment that goes into it. And today there are great partners like you, where I just don't need to do the investment. I just invest in the partnership and the interfaces, and then of course in the part and supply development course. But that's it. I think it might be also a blessing. Gen AI technologies, simulation technologies, all the tools that you really need to do autonomous driving. There is so much more today, both on the sensor, compute, and data and infrastructure area than it was about 3 years ago or even 5 years ago. So I think now is the perfect timing where you can, with much smaller teams, much less funding, achieve a lot. And then again, it's important what you're building. Do you want to build a tech demonstrator where you push the demo retrofit prototype to the ultimate end? Or do you want to design a product at scale into target cost? And then I think this partnership approach is super important. That's the only way how you meet your cost points. And in the end, in trucking there's almost no emotion. And trucking companies are pretty predictable creatures, which I like a ton. If you have a product that is safe and reliable and meets certain cost points, they will, and offers a 1-year payback, they will take it. If not, and you say it's a cool brand and it will help to support, they won't take it. They take one and put it in front of the headquarters, and that's it. So that's what I like about this, and that's why it's so important to have the right partnerships in place that you can meet these reliability levels and cost levels.
Makes sense. I know we're kind of coming short in time. I really appreciate you guys being here. Maybe we can end with one question on each side. So, Peter, on your side, to the extent that you can share, how do you think about the rollout plans from your functionality? How should the audience think about as Torc and Daimler Truck are coming to market, where we may first see these autonomous trucks on the road?
Yeah, that's pretty easy to answer. You will see them first on I-35 between Laredo and Dallas in the year 27. As a product, they are driving already here, that route and collecting miles every day. And we will scale from there. Our focus for now is US Class A trucking and Freightliner. And I always tell my teams, no hobbies. Let's solve this first and monetize it first once. And then afterwards, we can talk about no limits. No limits might be different vehicle classes, different regions, different OEMs, totally different applications. In principle, I like this level 2+ idea. So there or other things. So in the end, everything physical will need an AI that we are building. These are all the dreams. Now let's unlock our technology on I-35, Dallas, Laredo.
Of course.
Pretty soon.
Yep. And it's also great, exactly. It's also great to actually see these trucks already with our sensors equipped running, which is really helpful just to qualify them as we go towards SOP. So, and then Mike, from your perspective, how do you think about, as we talk about adoption of this kind of next generation, active safety technology, to the extent that you can share, where do you think that would be first visible and about what timelines?
Yeah, I think, first of all, 5 years ago, we would have thought L4 technology was, fully ramped up by now, and then this need to fill this time between L4 adoption, where you have the perceptions that you can mitigate virtually all accidents, maybe not all, but a large portion of it. Now we see that technology ramps up a bit slower, but that need for active safety systems and improvement in the active safety systems, the demand's there, and then we get to leverage the technology that's being applied to L4 a little bit earlier on the L2 systems, and really, again, bring that higher level of safety to the market much sooner. And we would see, a system like an integration like this with a 4D LiDAR as early as 28 or so, 2028.
Makes sense. Awesome. Well, I hope that gave you a bit of idea about the latest in trucking, both on autonomy as well as ADAS. We're really excited to have you here. Thank you again for joining us in New York City and taking time out of your busy schedules. But it's not about the chat here, it's about the work that we do every day. So we're looking forward to working together to bring full autonomy on the roads already in the next year or so, and then hopefully following that with commercial vehicles maybe even sooner. So I appreciate all your support, so thank you for joining us.
Okay, thank you.
Thank you. Of course, appreciate it. Okay, next we're going to have a panel with on the passenger OEM space. So I would like to, I think once they're ready, I would like to welcome our two partners, Marco Zoiner and Raid from Mercedes-Benz and Wideye by AGC. Awesome. All right. Well, thank you for joining us today. We've been having some conversations about trucking and autonomy. Try to ask, mostly, I think, kosher questions and maybe some things a little bit sensitive, but I think overall a good conversation. So, first of all, I want to thank you both for joining us here. Marco, obviously, from Mercedes-Benz and Raid from Wideye by AGC. Perhaps we can first start by doing a very quick intro from each of you about yourselves and what you do at your respective companies, and then we can jump in.
Yeah, okay. First of all, thank you very much for having us, or me here today. It's my first Aeva day, and it's quite an honor here to discuss the Fireside chat with you. My name is Marco Zoiner. I'm the head of ADAS hardware architecture at Mercedes-Benz. And I'm also responsible for all the ADAS hardware components that are necessary to build up an ADAS system. It is including all ECUs, also the central ECU, but also all the sensors. And this starts at LiDAR. This goes from radar, camera, ultrasonic, and so on. So everything, all the ingredients that you need from the hardware side to build an ADAS system.
Thank you. Right?
All right, so myself, I'm Raed El-Makhour. I'm Chief Product and Marketing Officer at Wideye by AGC, responsible for product strategy and roadmap and also marketing. So AGC is a global glass supplier focusing on architectural glass, automotive glass, and glass for electronics. And Wideye is a business unit within AGC taking care about sensor integration.
Makes sense, perfect. So why don't we jump in? So, I'm going to ask the obvious question on everybody's mind first. That's been going for a number of years, and I think a lot of folks talk about integration of sensing, including LiDAR and automotive. Maybe one or two don't. Can you talk a little bit about, there's this big debate about LiDAR and how critical really is it for ADAS and automated driving? Do you really need it? Obviously, from a Mercedes-Benz point of view and from your point of view, we'd also like to understand what you were seeing in the market. So perhaps we can start from there is, in the viewpoint of the need for LiDAR for automated driving, how do you see that from your perspective for the passenger car OEM space?
For passenger car, as Mercedes-Benz, safety is one of our key pillars of the brand core values. And we already had some experience there in implementing and developing systems, and we brought one of these systems to the market 3 years ago. It was the level 3 drive pilot. And when we are designing such a system, we think that redundancy is key. Redundancy in the system, and when it comes to sensors, we see that the use of a LiDAR is particularly indispensable for us, because besides, on the one hand, the traditional radar and the traditional camera, we see these three sensor modalities complementary, especially in their physical measurement principles. I give you an example. For example, when you're driving on a highway with 130 kph in a level 3 system, and suddenly your front cameras are dazzled by the low sun, you have the LiDAR on board and you have the radar on board, and these both sensor mentalities can take over, or they can take the load from the camera, and that's the reason why we think that redundancy is key here, and it is key that we definitely need a LiDAR for that situations. We can compensate the situation-dependent deficits of one sensor modality by the characteristics of another. And furthermore, maybe I have to add, all level 3 ADAS system as Mercedes-Benz use LiDAR as a standard technology. Because we have to fulfill high safety standards, we have to fulfill Sotereon standards, we have to fulfill FUSA standards, and this is only possible if you have these sensor modalities on board, including LiDAR.
Very helpful, and I think very clear, so I appreciate that. Ray, from your perspective, maybe talk a little bit about that. Obviously, you're seeing it from a different angle, but what do you see in the market about LiDAR?
Yeah, so we are seeing the same trend we have seen before for camera and radar. So we've seen that camera and radars ramped up in volumes around 2010, 2012, and we are seeing the same trend now. So most of the RFQs we are receiving from OEMs, we can see that most of them decided on adopting LiDAR. Maybe one or two are hesitating, also not omitting the Chinese OEM as well. So we are seeing this, let's say, trend settling that LiDAR is necessary to achieve redundancy, as Marco mentioned.
Makes sense. All right, so hopefully we answered that question, at least amongst this audience, around LiDAR. Now let's talk a little about, obviously there is different camps and technology. We are obviously biased. We are FMCW, a different camp than time of flight. But how do you view that, Marco, from your side of Mercedes-Benz, about FMCW and what that may be able to enable for you at Mercedes-Benz?
Yeah, we are observing FMCW for quite a long time, and we see that this indeed is a quite interesting technology because it provides additional information. For example, the velocity of a detected object. And this is really important for us, especially also in comparison to conventional lidars like time-of-flight lidars or something like that. And this, we can have advantages out of that for maybe specific use cases, like high-speed driving on a highway, where we suddenly have a lost cargo scenario. Detecting that lost cargo. But not only for highway use cases, but also for level 3 urban use cases, where you have various and fast-moving options in front of you. Here, these additional helps, and we are currently evaluating if this FMCW technology can provide us additional safety attitudes or application use cases for our customers.
Sense. And maybe continuing on, there is a discussion also after LiDAR versus no, yes or no, around the integration and where that needs to happen. For different use cases, as we go towards further and further advanced automation features, for highway application, you talk about for highway autonomy, for lost cargo, in which just for the audience, that means having an object that falls on the road that is maybe small or hard to see. As also Jessica shared that earlier, there are these use cases where with our technology we can have a significant resolution and pick up that static object from a small distance. But moving from those functionalities, there's also questions around where to integrate these sensors. There is a huge kind of trade space of what you can trade off in terms of performance, experience from the user, design, and others. Can you, maybe each of you talk a little bit about that? Maybe Ray, we can start with you since you have a perspective from the windshield side.
Yeah, so we've seen that LiDAR started, or OEM started integrating LiDAR in bumper since 2018, so we can name Mercedes, Audi, BMW, Lexus, Stellantis, and so on. But we are also seeing that this integration comes with a lot of challenges, which is good for us, otherwise we would not be here. So on a car, you have today a lot of sensors already. So you have, in each car we buy today, you have around 7 to 12 cameras, depending on the OEM. You have 1 to 5 radars, depending on the OEM. And now we want to integrate a third sensor that will ensure redundancy, improve safety, and enable OEM to reach higher autonomy level. So the first question to be asked is, how do I integrate the sensor while preserving performance, ensuring lifetime durability, and preserving vehicle design? And for this, you have 3 schemes of integration: bumper, roof, or windshield. And if we go into pros and cons of each this integration, so for bumper, the LiDAR is placed on a low position, so the LiDAR only sees what's in front of the car. You have a dead zone on the side of the car. Since it's a low position, it's also exposed to dirt. Mm-hmm. Hence, you would need a high efficient cleaning system, which means that you will need an additional cost on your bill of material. It's a low position also, so it's exposed to damage by stone chip impact, even if the glass that we developed is developed to withstand those stone chip impact. But basically, if you are parking your car and you hit the car in front of you, you could also have a damage of your sensor. And this makes it mandatory, or the OEM are seeking today to move from this position towards a better position to improve performance, but also design. And you have 2 candidates. The first one is roof, the second one is windshield. Roof today is seen as the best integration position. It's a high position, so your LiDAR is one meter higher, 1 meter backward. And basically, you have a better peripheral view. You can see the cars on your right, see the cars crossing on your left, and you can also improve early detection of crossing scenario, for example, a child or a pedestrian jumping in front of the car. You have a glass in front of the LiDAR, and this glass is tilted by 10 to 15 degrees. It is designed to have minimum impact on performance. So from a performance point of view, roof is the best integration today. But it's also challenged because you will have a bump on the roof, so you are pushed to change the design of the vehicle. And you have also effect on aerodynamics because you are adding a secondary skin that will increase the drag coefficient. But this glass could be also shaped in a way, and this is what we are doing with multiple OEMs. The glass could be shaped in a way to lower this drag coefficient. Last but not least, you have the windshield integration, and this is considered today as the grail of LiDAR integration. You would integrate a LiDAR behind windshield without impacting any form or any style of the vehicle, so the vehicle will look the same. You have zero impact on aerodynamics. You have shared resources with camera. You have cleaning that is already in place. But you also have a compromise in performance because the glass, even if it's improved for high transmission, the tilt angle of the windshield will give you some losses. And this is where we are working with OEMs, including MB and also Aeva, to try to find a way to overcome this. So as a conclusion, we can clearly see that mostly all of the OEM are dropping bumper integration, and now the discussion is between roof and windshield. The good thing is that at Wideye, we have the privilege to develop both products. Of course, we and Aeva, we can accompany the customer in their decision, but at the end, it's an OEM decision.
It's very helpful. So, you touched on, I think, a good point, ended up at windshield integration. Obviously, we're working together for some time on getting this vehicle integration concept done as well. We have a vehicle here with a fully functional LiDAR integrated behind the windshield. Maybe Marco, you can touch on this topic from a safety and autonomous functionality perspective. How do you see the integration location of LiDAR sensor in the vehicle impact the functions that need to be coming on as you see the roadmap?
Mm-hmm. So for our first generation level 3 system from 2022, we decided to put the LiDAR in the grill, in the radiator grill. And of course, we made experience that Red already described, like stone chip, like dirt. We have to clean the LiDAR and so on and so on. For next generations and for next systems and applications, we are thinking about alternative locations for the LiDAR. There is the position on the roof that you already mentioned, but also the position behind the windscreen. Both locations have various advantages, but also disadvantages in terms of integration. And we are currently evaluating these things together with you. But currently we have not yet decided what is the optimal position for us. But we know that we want to place the LiDAR higher because when we are looking in the future and have some, let's say, some roadmaps of level 3 and automated driving for the future in terms of level 3 or level 3 urban, we see that we have to position the LiDAR higher than in the grill.
Yeah. Very helpful. I think we covered a lot of topics around LiDAR, need of it, integration concepts, how that fits inside vehicles. Perhaps we can end a little bit about kind of your views on kind of where the sensing market and enabling next levels of automation is happening. So, obviously, as you said, Mercedes-Benz is one of the first OEMs now that has a level 3 functionality in the US, including LiDAR. How do you see that kind of generational technology? We talked a little bit about, some of the advantages that you could see with FMCW, enabling that for small object detections, for highway, perhaps urban with fast-moving objects in and out of the scene. How do you see to the extent that you can talk about the roadmap of the functionalities that need to happen in the market from an OEM's perspective in terms of autonomous driving? So first be the highway, is urban right after that? Is there something in the middle, or how do you think about that?
Mm-hmm. So we started with the highway application, but currently we see a strong push for level 3 applications, especially from the Chinese market. And we see on the roadmap that this will also be extended from highway to urban scenarios, and also in the direction of level 4 driving, but also parking. And of course, we are following the trend because we want to be competitive in all markets worldwide. And therefore, I see this push can be a benefit for the whole ADAS community worldwide. And of course, we are a global acting company, and we will bring that new systems and that new applications towards level 3 and level 3 urban, definitely worldwide to the market, not only for the Asian market.
Makes sense. Thank you. Ray, your perspective on functions?
So yeah, we are clearly seeing OEMs focusing on highway, but also urban scenarios, how to improve safety and in urban scenarios. We are seeing two schools here. So global OEMs started by highway pilot. China OEMs are more into urban scenarios, and now they started by improving level 2 by using LiDAR and then going to level 3. Global OEMs are more enabling a higher autonomy level, which is a level 3, and then checking how would I deploy my LiDAR in a mass scale towards my mid and low end segment for urban scenarios.
Awesome. Well, I want to thank you for joining us here today. Really appreciate your perspective. I just want to add that, from our perspective, what this all means for us is, obviously, as you highlighted, from a Mercedes-Benz point of view, there is, you see LiDAR as standard technology. We have been working on bringing the technology to mass production, starting with trucking space, now transition to passenger. And I think the economies of scale that we see from the innovations and investments we have made over the past number of years are starting to pan out. And as we deploy that first in automated trucking and then passenger, as well as active safety for commercial vehicles, because of the fact that we can use one perception platform, it's manufactured on the same line across these products, as well as the other markets that we have talked about. We'll touch on more later today as well. We're really excited about the opportunities ahead we have together with you, and we're looking forward to bringing this technology to mass production. So thank you for joining us, and with that, I'm going to move on to the next segment of this.
Thank you.
Thank you.
Thank you.
Next, look at manufacturing automation, where the demand for precision displacement sensing is undergoing a revolution. My name is James Reuter, Chief Engineer at Aeva, and I will take you through the exciting breakthroughs delivered by Aeva's precision sensing and how these sensors fit into the evolving demands of this market. Let's start by understanding what this market is all about. Due to its rapidly transforming demands, the manufacturing automation market has grown to over $14 billion. First is quality. The market is segmented into several areas. First is quality control, where the automated micron-level precision inspection of components is now routinely performed in real time on assembly lines. Quality control is also using displacement sensors to perform component shape measurements by robotic inspection. Next, automated assembly is another domain experiencing changes in precision sensing needs. Precision real-time distance measurements are required to determine the exact location for automated assembly robots, as well as pick-and-place machines. Aeva's displacement sensors are ideally suited to meet this needed micron-level measurements. Vibration and speed sensing is another market segment that is uniquely addressed by Aeva's sensors. Our sensors are differentiated by the fact that they measure both distance and velocity simultaneously. Observing the vibration of rotating machinery provides direct health monitoring, while sensing the speed of a conveyor system improves the efficiency. These market segments and many more, Aeva's entry in precision sensing is disruptive and transformative. At a top level, this market is broken down by the sensor's functional capabilities. For example, 1D sensors that measure distance, and in the case of our sensors, velocity, do so along one-dimensional axis. Sensors of this type are used for distance and sensing, as well as velocimetry and vibrometry. 2D inline scanning sensors are used in such applications as dimensioning, volume measurements, and gap and flush inspection. Finally, for 3D or area scanning, high-precision depth sensors are entering and expanding the market via use cases such as 3D inspection, robotic guidance, and distance metrology. Aeva can capture these markets using one platform architecture. So why is Aeva's FMCW sensing so revolutionary for manufacturing automation? Simply put, Aeva sensors completely change the way precision sensing is done. Let's take a look at how competing sensors in this market function as compared to Aeva's approach. A large percentage of 1D precision depth sensors use the principle of triangulation to measure depth. Unfortunately, this technique has several significant shortcomings. First, to measure distance at a micron level, triangulation sensors must limit their operational depth of field. A more significant problem with these sensors is when scanning complex parts with steps, ridges, or troughs, the sensor is unable to perform its basic function due to the target itself blocking the light path. Another frustrating challenge in the use of triangulation sensors is that you must use different sensor designs for different standoff distances. These design restrictions are typically limited to 1 meter standoffs. In contrast, Aeva 1D precision sensors use coaxial light path and interferometry to measure distance. The advantages of Aeva's approach is why we are upending the manufacturing automation market. Instead of limited operating depth of field, Aeva sensors can provide a wide range of measurable distances for given standoff distances. Further, due to the coaxial light path, Aeva sensors never suffer from occlusion errors present in triangulation sensors. In perhaps the most important aspect, the size and even the design of our sensors does not change as a function of the standoff distance. Everything from 100 millimeters all the way up to 20 meters can be addressed by a single compact form factor. This feature alone opens the door to many new applications for our sensor. However, the benefits of our sensing architecture do not stop here. Not only do Aeva sensors precisely measure the distance as well or better than our competition, but we also simultaneously measure radial velocity, which our competitors do not. This means Aeva can provide the same sensors to our customers to inspect depth, monitor vibration, or even perform both simultaneously. Finally, with a small adjustment in the optics, we're still within the same design. Aeva also measures tangential velocity and hence can monitor the speed of conveyor systems. In this chart, we see how triangulation sensors compare with Aeva sensors. We see different triangulation sensor designs are needed for different standoff distances. That measurement precision degrades with standoff distance and ultimately are limited to standoff distances of 1 meter. By contrast, a single Aeva sensor design is applicable to standoff distances from 0.1 to 20 meters, and most importantly, we can maintain the same high-level precision over that entire standoff distance range. So the bottom line here is that Aeva has introduced one compact and versatile design that addresses multiple manufacturing automation market segments. All of our new Aeva sensors leverage the same core technologies that Mina and Jessica covered earlier. This includes our core vision module containing all of our photonics, lasers, and detectors, our perception software, and our internal calibration procedures that provide for the micron level depth precision. Eve 1D is our 1D displacement sensor ramping to mass production this year and providing high precision depth and vibration sensing. Eve 1V is our 1D tangential velocity sensor that allows customers to measure speed and of conveyor systems with high accuracy. For all these reasons that we have discussed, unmatched performance over a wide range of standoffs, a lack of limitation due to occlusions, providing both displacement and velocity from one sensor, a common architecture and design for all applications, the leading companies in this industry, including Nikon, SICK, and LMI Technologies, have chosen Aeva. Now let's hear from one of our partners at LMI Technologies.
At LMI Technologies, we provide our customers with the latest technology focused around industrial automation. Our products enable our customers to build better products through quality control, robotic guidance and automation, and inspection. We're very excited about partnering with Aeva due to their unique FMCW LiDAR technology. This really represents the next generation in terms of a technological leap in what's capable for measuring very, very precise surfaces at incredibly high speed. What impressed us most about Aeva's Eve 1D product is its ability to have unmatched precision and measurement speed. This allows us to measure at sub-micron levels out at multiple meter distances, with incredible dynamic range, allowing us to get excellent data quality regardless of lighting conditions or the surface that we're measuring on. We see this as a core piece of technology that we'll be able to integrate into future products, allowing us to bring this capability to multiple different industries and applications. With Aeva's FMCW LiDAR and chip technology at its core, Eve 1D offers exceptional precision, repeatability, dynamic range, and robustness that we haven't seen in other solutions. It's automotive-grade tech, now applied to industrial-grade challenges, and that gives us confidence in both its reliability and long-term potential. We're excited not just about what Eve 1D can do today for displacement sensing, but also about where this platform can go, from inline inspection to advanced 3D guidance and robotics. Aeva's precision algorithms and software-defined approach make this a sensing platform we're looking forward to leverage and build on. We're proud to partner with Aeva as an early customer and excited to be part of this next chapter in precision 3D sensing.
Okay, we'll now go to a fireside chat in the area of automated manufacturing, and I want to welcome to the stage Mr. Mori, VP of Engineering at Nikon. So let's start by having you introduce yourself and your role at Nikon.
Okay, so my position is now is a VP engineering in the Nikon Metrology Inc. My role is to develop laser radar product, not only the develop, but also some manufacturing engineering or some manufacturing support also. But my career started from 1999 as Nikon employee. So from 1999 to the 1915, I was a Nikon headquarter engineer for the semiconductor business. Now, after that career, I moved to the Nikon metrology side. So, which means I moved from Japan to US to start my career as a metrology business.
I see. Can we do a bit of an overview of Nikon's metrology business? You can help the audience understand the use cases and how Nikon's fits into this market.
Okay, sure. Nikon Industrial Metrology Business Group is a market leader in the metrology sector and covers a range of technologies from microscope and video measuring system, like a 2D product, to the X-ray product and the laser product, like a 3D product. So this means we can offer the customers the right solution for their methodology needs across a range of markets, including aerospace, automotive, electronics, energy, R&D, and general manufacturing. We can measure every from the smallest, like a integrated circuit board, to the largest, like aircraft. It's not only outside, but also inside.
Yeah. You know, Aeva and Nikon have been working together now for several years, and with Nikon really looking at FMCW chip-based technology for their next generation metrology. Can you share more about why this decision occurred and why Nikon has been so interested in Aeva's FMCW technology?
Sure. At Nikon, we are always assessing new technologies and the ways that those can be utilized within our product range to improve our products for our customers. So our existing laser radar product already leveraged the FMCW technology. So when we heard about the silicon-based FMCW module from Aeva, so this provides a natural fit into our laser radar product line. The compact form of the sensor creates a wide range of the possibility to improve our existing product line and create solutions that are on the cutting edge of what is possible with precision laser measurement.
So you commented on the fact that it has a compact form factor. Your current methodology, as you mentioned, uses FMCW already, but of course it may not be the same form factor. So can you comment on some of the limitations of what you're doing today versus how that will change towards with FMCW and Aeva?
The traditional optics metrology system rely heavily on the complex optical architectures and the components, causing system to be bulky and heavy. But reducing the complexity and the optomechanical elements through the use of the Aeva sensor allows for simplification of the design and the reduction of the size of the instruments. This will provide an overall better system, more suited for the industrial application and measurements that require high accuracy in harsh environment.
Do you think that Aeva's technology unlocks capabilities that weren't accessible from your previous technologies?
Yeah, the on-chip setup and the high-speed Aeva technology allows us to design the next generation products that are better focused on the emerging trends of the manufacturing industry, namely 100% inspection of the components during the production process to ensure high quality of the produced components. The high data rate of the Aeva chip provides a huge amount of the good quality inspection data to enable better decisions.
Yeah. Can you comment a little bit about what products in the Nikon roadmap you believe the Aeva LiDAR will actually fit into?
At Nikon, we are always developing new solutions for customers. And the Aeva sensor will be integrated as part of our future offering down the line. In addition to the laser radar product, we are exploring using Aeva sensor in other Nikon products also, so within our vision and robotics group.
Okay. Looking ahead, perhaps we can talk a bit about the expansion opportunities. How do you see the combination of Nikon's metrology expertise and Aeva's FMCW technology expertise coming together?
Nikon metrology has extensive experience with precision optics and measurement. And we proud ourselves with our quality and leading edge technology integration. We are always striving to provide the best solution for our customers, and the Airbus FMCW sensor is key in that. We see the industry trend going to more integrated metrology solution, requiring the latest technology to provide the high quality data to ensure high quality components. The ability to provide the lots of high quality data allows customer to use emerging technology such as AI to better control their processes, feeding information backward and forward in the manufacturing process, reducing scrap and rework, and ultimately saving them money. So combining the precision optics expertise of the Nikon metrology with the cutting edge technology of Airbus silicon chip will allow us to create the best solution for our customers.
I see. Thank you very much. I want to thank you very much for coming on and having a conversation.
Good afternoon, everyone. My name is James Bian, Managing Director of Business Development at Aeva. It's great to be here today. Aeva is on a mission to bring new levels of intelligence, precision, and safety to how we move. Not just in the vehicles on the road, but across airports, railways, cities, and even the skies above. Today, I'd like to walk you through how our 4D LiDAR technology is transforming the smart infrastructure and transportation industry. A fast-growing market we estimate to be over $8 billion. We'll focus on three major areas where we're seeing momentum: airport and venue operations, traffic management and enforcement, air and rail transportation safety. But we didn't start from scratch. At the heart of our expansion is Aeva's unified perception platform, the same technology that powers next-generation vehicles. Our products for smart infrastructure share the core vision module, the X1 chip, and our proven automotive-grade perception software. With power and data delivered through a single cable, we've truly created a plug-and-play solution for the partners building scalable systems in complex environments. Let's start with airports and transit hubs. Aeva's 4D LiDAR is deployed at Tampa International Airport and the new Terminal 1 at JFK, two of the busiest and most innovative hubs in the United States. In partnership with Sotereon.ai, a leader in LiDAR-based perception analytics, our sensors enable airports to track crowd density and flow, detect fire and smoke in real time, and support emergency response and evacuation planning. Unlike traditional systems, we can segment moving objects, even in dense environments, and measure their instant velocity, helping airports improve safety and the passenger experience. Now, let's take a look at what our partners had to say from Sotereon.ai and Tampa International Airport.
An airport is no different than a city, right? So you've got safety issues, you've got cars, you've got buses, trams. So if you look at building a platform for an entire airport with LiDAR, there are multiple opportunities for safety, security, revenue, and passenger experience.
We're a origination destination airport, so our world starts at between 5 and 6 a.m. when you can see the peaks. The problem in the industry right now is that everybody is busting at the seams. Everybody's under construction, everybody's trying to expand, so you have to become more efficient. So technology has become critical to ensure that you're getting the most efficient use of the square footage in your terminal that you possibly can.
Aeva's vision of the future of LiDAR is ahead of what I'm seeing from the other LiDAR companies. They kind of saw around a tech corner before anybody else did, and they built it. And so we're starting to see the possibilities of LiDAR become endless.
The LiDAR sensor is telling our system when the lobby is cleared. Then it immediately tells TSA on the other side to know what's coming. So when the volumes are starting to get heavy, they know what's coming to them as well. There's a lot going on. You got 13, 14 solutions spinning out there. We have smoke and fire and parking solution that we're finalizing and rolling out right now. You have the gate hold area. You have the concessions, but you keep raising the bar of every solution that you put in place. And we're a tough customer. We are a tough customer to work with because we have high expectations.
We picked our partner in the LiDAR space that has now started to deliver things that we didn't even think about a year ago. You know, I see all these others talking about it, but then you got to actually build it. And Aeva's ahead of the game by probably a couple of years.
We're at the point now that we're making a difference in the industry. That's the exciting part. And it's another facet that makes Tampa International a little better than everybody else. And that's always your objective.
Our technology is also trusted to protect some of the most sensitive infrastructures in the world. In collaboration with Sandia Labs, we're helping secure nuclear facilities by enabling real-time detection of hard-to-spot threats, such as small watercraft and restricted zones. With Aeva's unique velocity data and 3D accuracy, a system can distinguish between benign and suspicious movements, giving operators more time to assess and respond. Now, let's turn to roads and intersections. We recently announced our partnership with D2 Traffic, a leader in intelligent transportation systems. Using Aeva's high-resolution data, D2 is enabling smarter intersection control, more accurate vehicle counting, and real-time situational awareness for traffic operators. Traditional sensors often struggle in poor weather conditions or dense traffic. Our solution provides reliable data, day or night, rain or shine, and gives the city the tools they need to manage traffic more efficiently and safely. Let's hear from our partner, D2 Traffic.
When you pull up to any intersection, you see a lot of wires, you see a lot of lights. It's full of technology, and it's technology that's all geared around safety.
We've got the perfect field of view of this intersection from that position.
D2 is a traffic technology company, and we really felt there was a place for LiDAR as the detection of the future.
Look at the range on this image.
Cameras have been in the marketplace for quite a long time, but there's restrictions with cameras. If it's at night, it's too dark, it's a problem. If it's a snowstorm, it's a problem. LiDAR has the ability to see at night, it sees through inclement weather, and it can give you sub-centimeter measurements. So it can be very, very precise. Now, D2 has become the company that's known for LiDAR. So we speak about it with authority. It's not that we're selling the product, but we're selling a solution.
We've got the Aeva Atlas sensor up here, which is a new technology of LiDAR. It's called a 4D LiDAR. The real advantage with 4D LiDAR is it's no longer using a time of flight. It is a continuous wave frequency modulation. It can tell whether the object it's hitting is going away from it or coming towards it. And it also gives you very accurate velocity data right from the sensor.
We were excited about working with Aeva because the 4D technology that they're bringing to market, we think really has the ability to be a game changer. It's adding intelligence to the intersection. It can determine whether there's a pedestrian crossing and the light's going to change or not. It'll monitor the way the traffic is moving and try to make it possible so you don't have to stop. So it allows the roadways and the highways to be more efficient. Are we doing red light running here?
Yeah, we're monitoring for red light running as well as wrong way driving. You can see our advanced zones set up here.
Every major LiDAR manufacturer that wants to be in the ITS space has approached us. And we really believe 4D LiDAR is going to prove itself out to be the most reliable form of detection.
We're also scaling through partnerships in automated traffic enforcement. Last year, we joined forces with Sensors Gasso Group in Australia. With 50,000 deployments in over 70 countries, they are one of the most experienced players in this space. Sensors Gasso is using Aeva's 4D LiDAR to provide independent speed validation that complements their core radar technology. From school zones to highways, our joint solutions brings fairness and accuracy to traffic enforcement around the world. Finally, we're bringing our technology to the frontiers of rail and aerospace. We are proud to be working with Deutsche Bahn, one of the world's largest railway operators, to explore automated rail safety applications. In the skies, our partnership with Airbus UpNext, the innovation arm of Airbus, is focused on enabling advanced perception for next-generation aircraft systems. This isn't just about automation. It's also about preventing accidents that come with significant costs. According to the International Air Transport Association, the cost of ground damage to aircraft could reach $10 billion annually by 2035. By equipping aircraft with 4D LiDAR that can detect nearby planes, service vehicles, and ground personnel in all weather conditions, Airbus is exploring how to reduce risk, maximize operational uptime, and improve safety from gate to runway. These are innovative programs, and they all have one common foundation: the need for fast, accurate, and reliable perception in complex and safety-critical environments. Aeva is enabling new era of intelligence across transportation and infrastructure with a common technology platform that's proven, scalable, and ready to deploy today. We're honored to be working with leaders like Sotereon.ai, T2 Traffic, Sensors Gasso, Deutsche Bahn, and Airbus to help shape what comes next. And now, I would like to share a short video of our collaboration with Airbus to give you a glimpse of that future in action. Thank you.
Hi, everyone. Hope everyone's been enjoying the first part of Aeva Day. We're now going to take about a 10-minute break so you can stretch your legs, maybe grab a drink or use the restroom. We'll start about 3:20, the next presentation. Thank you.
Okay, all right, everybody. Well, I hope you had a good short break. Thank you for being here again today. We're going to continue the next segment of the presentation with a special keynote speech by our strategic partner, LG Innotek. So it's with great honor that I would like to introduce Dr. H.S. Moon, CEO of LG Innotek. We'll first start with a short video by LG Innotek, and then he will come on stage. See you soon.
Good afternoon, everyone. Thank you for the introduction, Soresh. It is an honor to be here with all of you today. Let me begin by thanking Aeva for inviting me to speak at Partners Day. I'm truly grateful for the opportunity. As I traveled here from Korea, I look forward to today. Now that I'm here, it feels even more meaningful. LG Innotek was founded in 1970 as South Korea's first electronic components company. Since then, we have focused on innovation and collaborated with customers across many sectors. This journey has taken us into fields like home electronics, smartphones, automotive, AI, robotics, and more. Today, I believe is the beginning of a new chapter. It is a chance for us to explore new ideas, align our visions, and move forward together. Today, the global market is changing fast and in ways we cannot always predict. We see new technologies emerging every day. Trends such as autonomous driving, robotics, and AI used to belong to science fiction. Now they are part of today's reality. And right now, we are at the center of these changes. Please take a look at the S-curve on the screen. You may recognize this shape. It shows how most technology evolve, rapid growth, mainstream adoption, and eventual decline. So where are we on that curve? Where is LG Innotek today? Where are your organizations? And most importantly, where are the customers and markets that will shape the next curve? We aim to be the reliable technology partner for paradigm-shifting companies, enabling our customers' aspiration to drive future transformation in electronics, mobility, and robotics. This is our vision. It is not just a statement. It reflects our commitment to building the next S-curve with our customers by growing together. Our partnership with Aeva is built on this shared vision for the future. It is more than a financial investment. It is a strategic alliance based on mutual belief in each other's growth. Together with Aeva and with all of you, we will chart a new S-curve. With Aeva's cutting-edge technology and foresight in autonomous driving, and with LG Innotek's core technologies, proven manufacturing capabilities, and commitment to quality, we will create a powerful synergy. We are here to accelerate innovation, to push boundaries, and to set new standards in next generation mobility. I invite each of you to join us to help shape what is next together. As we begin this new chapter, I feel confident in what we can accomplish through shared vision and collaboration. Thank you once again for your time and presence today. Together, let us aim higher, achieve more, and contribute to a future that benefits all of humanity. Thank you.
Awesome. Thank you. Thank you all for listening, and thank you, David, for coming. So we're going to have a fireside chat with David, who is Dr. David, who is the CTO for LG Innotek. Dr. David is a recognized leader in laser and sensing technologies, career in Silicon Valley, Korea. At LG Innotek, David runs all R&D, technology strategy. He's responsible for advanced optoelectronic devices, packaging, precision packaging. I would say he was very instrumental in the large-scale development and deployment of the world's first 3D sensor in consumer devices. It's probably one of the biggest things. And I think, to say the least, his work continues to shape the future of optical innovation in both industry and academia. We're very, very honored to have him here with us today on this fireside chat. David, thank you very much for coming.
Thanks for having me.
Absolutely. So maybe to kick it off, one of the things maybe that probably the audience would like to hear is, share for us why LG was interested in LiDAR and the importance of LiDAR in the LG Innotek portfolio, for example.
Okay, let me start off by saying that LiDAR technology is neither unfamiliar nor new to LG Innotek. LG Innotek is still making hundreds of millions of laser modules each year. And these laser modules go into 3D sensing and distance measurement, just exactly what a LiDAR is. So for us, having a lot of experience in laser technology, precision optics, as well as very ultra-precision alignment, our foray into the LiDAR sector is just a natural expansion of what we're already doing. Also, LG Innotek is a significant presence in the automotive camera sector. So obviously, being in the camera sector in the automotive side, being able to add a separate modality of sensing is a very important and a core criteria for our product roadmap.
Yeah. I guess one thing to add on that is we see the same thing. You know, we see how Innotek has all of these expertise in delivering such a product in mass volume. We, of course, have seen some of your CES booth, how you have continued to show some of your previous LiDAR, and obviously we're very excited to partner with. But maybe jumping up to another area, which is how do you see that partnership with Aeva? Why did you choose Aeva to partner with?
So, as you just mentioned, Mina, that LG Innotek has demonstrated our LiDAR technology every year in our CES booth over the past few years. So we have, over the years, evaluated and tested very, very different and a lot of different LiDAR technology platforms. And when we were first introduced to Aeva's technology, what was especially impressive to me was the fact that it was a very elegant solution into being able to bring FMCW technology in a mass-producible manner. I think there are many FMCW companies out there, but I felt that the approach that Aeva has taken was the most practical as well as the most elegant way to move forward at this time.
Yeah. Maybe just something to add, and I guess I mentioned it in the speech as well. When we first started, we actually had to come up with an architecture that we know can be scalable. And there was options and ideas about how to make it more fancy, but some of these were not yet practical. The technology was not available. And that's, I guess, one of the reasons why we had to do this platform, design it in a way that we can go across multiple markets, but more importantly, in a way that we can manufacture it at scale. So, I mean, of course, we're happy that you have seen the same thing, but that's something that I would echo also on our side.
I would like to also add that earlier you mentioned that you are leveraging proven telecom technology. So, having been in the laser industry for some time, I know how rigorous the telecom laser and transceiver type of technologies need to pass the rigorous tests in reliability and performance. So, it was an additional plus that I was using a proven telecom leverage assembly techniques in making one of your key components in your LiDAR.
Yeah, I mean, I could argue there has been billions of dollars invested in the telecom industry. It is no surprise that we would try to use it. I completely agree, and frankly, it is one of the reasons why where we are, is that we have been able to use these technologies, these processes for our advantage.
So let me ask you a question here. So what does Aeva see as a potential applications that are additional to what we already talked about today? What other areas are you truly excited about?
I guess there's a couple of areas, to be honest. I mean, obviously, one of the key areas is automotive. I think it touches the safety of people. This is one area that, I'm personally interested in taking all the way through. And I think we are seeing the right interest from our partners, DT and others. And we see that FMCW will play a very key role, like we have seen from Jessica, and how FMCW has the ability to detect the small objects on the road, has the ability to detect this long range objects, 500 meter plus. So that's one of the areas I would say. Now, I think another area that I touched on, and I think I mentioned in my initial talk, is on the health and biometrics and areas that it is probably not easy understandable what it can do, because this technology has the ability to measure down to microns, vibrations, completely remote, meters away. You don't know yet what is possible. And with the ability to integrate this in a much smaller form factor, put it in robots, these are things that I think it is unclear yet what it would be. But I think the opportunity is massive, frankly speaking. And this is one area that I'm personally very excited about.
You just mentioned robotics as one of the possible applications, and from LG Innotek's perspective, all the sensor modalities that are needed for autonomous vehicle is identical as what needed in making autonomous robots. So they also need to be aware of their surroundings. They need to be able to sense small objects. They're all the things that Aeva is working towards in the automotive sector I think is almost directly applicable in the robotics space. And LG Innotek is particularly interested, and we are excited about our potential collaboration in that sector as well.
Yeah, good to know. Maybe something question from my side here is, as you are focusing on your large market presence, your focus on scale, your capability, what is the critical focus for the future technology in sensing, hardware, and software?
So obviously, given our very large presence in the camera sector, being able to make hundreds of millions of modules each year, what we really are driving towards is a marriage of multimodal sensors, meaning that in addition to cameras, we need to have complementary and supplementary technologies that can support the shortcomings of camera-only approaches. So having a multimodal sensor solution that is added with the perception software, I think that is the major direction that every maker is looking forward to making, and be able to provide a very attractive solution for potential customers out there. So I think multimodal, I think, is the key word, not only just LiDAR, but LiDAR plus camera. I think this was mentioned earlier in some of the automotive sector as a place of interest. So I think those are the areas that we will be focusing on in the near future.
I guess maybe shift a little bit gears. How do you see the collaboration so far between LG, Innotek, and Aeva? From your point of view, how has it been, and also probably for the audience as well?
So I don't want to get too deeply into technology at this point, but after all, we are CTOs, right? So maybe we should talk about technology a little bit. I'm particularly interested, I'm impressed that Aeva has a lot of in-depth knowledge about laser devices, as well as semiconductor processing. Although on your slides it just says lasers, you and I both know what type of in-depth understanding of semiconductor physics and photonics and optoelectronics all need to come together for you to make be able to make FMCW lasers. So I think starting from that aspect is where LG Innotek and Aeva can work together. There's also what LG Innotek has been developing in terms of our LiDAR platform in the past. I think those complemented with Aeva's FMCW technology could be very attractive solution out there. So our near-term collaboration will be focused on marrying existing solutions that both companies have and be able to come up with something that's more than just 1 + 1, but maybe 1 + 1 = 4. That's the type of solutions that we'll be working on.
And I mean, obviously we have talked about both of our roadmaps. It is going to be very critical in the long term as well as in the short term, how to marry both of these. And maybe one thing to add on the collaboration side, we have multiple projects we're already working on. We're going to be releasing products very soon that is based on these collaborations. We have a couple of products, and more importantly, we have customers interested that we are both talking to that are seriously interested in both of these applications.
Just so that the audience knows that we actually, LG Innotek engineers are working jointly with Aeva's engineers on site. So in your Mountain View office, we have dispatched our engineers, and they're working side by side. And we would really much on track, we like to be on track to be able to show the world of something of our collaboration, and sometimes in 2027 is what we can both expect.
Maybe one other question I have, and I'm sure the audience would like to hear, is how do you see the path for LiDAR and how would it go towards commercialization? How do you see that in the future?
So I think earlier, one of the Aiva's presentation mentioned that LiDAR, maybe 5 to 10 years ago, LiDAR was something that was an R&D project. It was something that works well in the lab, but doesn't work that well in the real world. I think Aiva's changing their paradigm on that. I think some of your real world application is showing how practical LiDAR technology can be. So moving into the future, I think we can imagine the world where LiDAR technology goes into devices that we haven't even imagined yet. Earlier you mentioned a slight topic on that, and I would like to add that with the advance of physical AI, now the world is trying to understand the world in 3D and be able to map that 3D world into the physics world. So I think for the physical AI aspect of it, we can start imagining many more devices and many more applications that uses a high precision 3D mapping of the world and how that can be fed into AI models that correctly describe the kinetics and other aspects of physics. And that will enable new classes of products. And I think that's the direction that I believe you and I, when we compared our technology roadmap, I think we saw commonality in that type of ambition that we have. And I think that's the aspiration that everyone in this field should look forward to having.
I completely agree. And with that, I think, thank you, David, for coming. I appreciate you coming. And next, we will have Susan, who will come and talk about manufacturing.
Thank you.
Thanks a lot.
Welcome to the manufacturing section of Aeva Day. Today, you heard from Soroush about Aeva's history and accomplishments. You heard from Mina about our technology and perception platform. And you heard from key strategic partners and customers about our exciting market opportunities. So the question you're asking yourself now is, can Aeva scale? I'm Susan Hayes, the Vice President of Manufacturing and Supply Chain. And today, I'll walk you through our plan to scale a perception platform. Our manufacturing strategy focuses on 3 key principles: simplicity, automation, and scale. Our years of unique IP investments have allowed us to develop solutions that bring simplicity to the forefront, enabling on-chip integration within a massively simplified design. Our technology is purpose-built for full assembly automation, ensuring both efficiency and scalability, leading to the launch of our first mass production FMCW line later this year. We collaborate with the most capable partners worldwide, experts in optics, automotive, and industrial manufacturing. Together, we're shaping the future of sensing and perception manufacturing. When we talk about our massively simplified design, we start with our silicon photonics, where we've combined multiple optical functions on a single integrated chip. This allows us to operate at chip scale, compatible with standard foundry processes, full wafer scale testing, and advanced packaging for integration with our optical module core vision. The result is over 80% component reduction from our first generation products. Less components means lower cost, faster assembly, and higher quality. It also means that all complexity is removed from the top-level sensor manufacturing, allowing us to leverage standard manufacturing process with no active alignment needed. Because of our photonics investment, we can now tap into a full ecosystem. Silicon photonics is no longer just a research topic. It's a scaling technology with billions in investment and accelerating demand from AI data centers, telecommunications transceivers, and sensors. This investment is also driving manufacturing process development that Aeva can tap into to leverage and deploy to create a fully hermetically sealed optical module. In order to deliver this high-quality, reliable LiDAR at scale for safety-critical and high-volume applications, automation is key. Optical assembly requires a high level of automation to achieve our micron-level precision. We use proven high-volume processes, including die bonding, seam sealing, and optical alignment, again, with no complexity of handling fiber. Over the past 8 years, we've invested millions in advanced assembly, test, and automation equipment at Fabrinet in Thailand, enabling us to scale while maintaining high quality and reliability. Our dedicated work cell is a Class 6 clean room, fully equipped to assemble and test our integrated core vision modules. For the final assembly of our product, Atlas, we've partnered with Jabil's Automotive division in Chihuahua, Mexico, to build a state-of-the-art, fully automated line, capable of ramping to 200,000 units annually, or one sensor every 70 seconds. Our surface mount line is fully automated and includes end-of-the-line inspection using both optical and X-ray. We have automated every process, from pick and place, to screw installation, to board connector press fit and dispensing. Each work cell uses 2D or 3D vision to ensure our assembly quality. We're also deploying a full end-of-line test and calibration system with a rail-based transport to move the LiDAR units automatically between test stations. We'll deploy this line to production in Q4 of this year with 10,000 square feet of a Class 8 clean room. We heard from Mina about our platform approach. This also brings big benefits to production and to operations. It lowers costs by using fewer parts and simpler assemblies. It speeds up manufacturing with common designs that are easy to build and automate. It improves quality by reducing variation and defects. And it makes scaling easier, helping us ramp up faster across markets, product lines, and new markets. Entering the automotive market is exciting, but it's also unforgiving. Safety, reliability, and consistency are non-negotiable. That's why Aeva has made significant advancements in our quality management systems. Our certifications speak for themselves across ISO, cybersecurity, and automotive software. Yes, there's an upfront investment, but the return is real. Faster product ramp, fewer defects, and stronger customer trust. The last facet of our manufacturing strategy is partnering with world-class manufacturers, which gives Aeva major advantages. LG Innotek, our strategic partner, is recognized for their manufacturing excellence in the automotive sector, and they'll produce our Atlas Ultra sensor. For our silicon and photonics, we have a 6-year relationship with Tower Semiconductor, who you'll hear from later on our manufacturing panel. Our X1 chip is produced by TSMC, the world's largest semiconductor foundry. All 4 generations of our core vision module have been assembled by Fabrinet, one of the world's largest manufacturers of optical components. For our final assembly, our partnership with Jabil gives us access to IATF-certified facilities wherever our customers require. By leveraging these partners, we get access to cutting-edge facility, tools, and expertise without the cost or time to build them ourselves. Not only do these partners handle complex manufacturing, but they help us design for faster, easier, more reliable production and testing. Their strong quality systems reduce the risk of product failures and protect our reputation. They also manage the full supply chain, from parts to delivery, using their global networks to cut costs and reduce risk. Ultimately, Aeva's manufacturing strategy of simplicity, automation, and partnerships help us scale efficiently and confidently, turning our manufacturing into a competitive advantage. I hope I've answered your question on how Aeva can scale. Thank you. For the second part of our manufacturing session, I'd like to welcome two of our key partners to join me here. We have Waqas Khan, Assistant General Manager from Tower Semiconductor, and Chad Morley, Senior Vice President of Automotive and Transportation at Jabil. Welcome.
Thank you.
So a key part, as I talked of our strategy, is partnering with world-class manufacturers like yourselves. So let's kick it off today with some introductions. Tell us a little bit about yourself, your role, your company. Let's start with you, Waqas.
Yes, thank you. We have been at the forefront of silicon photonics technology from a very long time. I've been involved with Tower for 20 years, and we have manufacturing capabilities all over the world, including multiple factories in the US. And I've been involved on the business side from the very beginning, including 6 years, what I remember, with Aeva all the way through on the silicon manufacturing side.
Excellent. Chad?
First of all, thank you for having Jabil represented here today. My name is Chad Morley, and I represent Jabil Automotive and Transportation Division. If you don't know what Jabil or heard of Jabil, Jabil's a $29 billion contract manufacturer. We have about 100 manufacturing sites globally in 30 different countries, and we really support multiple end markets, automotive being one of 8 different divisions within Jabil.
Great. Thanks for the intros. One of Aeva's key advantages has been simplifying our product through silicon photonics. The silicon photonics market is growing rapidly through adoption through AI data centers, and we're also poised to see an increase through from LiDAR sensors. So Waqas, is this Tower's view as well, and how is Tower preparing for this type of scale?
Very good. So silicon photonics has become very, very significant over the last few years. Tower, as the leader in the market, we have, I think, 70–80% of the market on silicon photonics manufacturing. We've basically have had to increase our capability on silicon photonics by multiple folds over the last 3–4 years. And we are putting hundreds of millions of dollars of new investment in CapEx, as well as increasing our capability in more than one factory for silicon photonics. For capabilities to serve companies like Aeva, to scale things as we go into the future, not just for datacom, but also for LiDAR and new emerging technologies like medical, sensing, and quantum stuff as well.
Great. Another benefit of our chip scale integration is it dramatically simplifies our design and allows us for automation. Aeva views automation as critical for achieving the quality required by especially our automotive customers. Jabil's approach to automation was a key differentiator and part of our partner selection. Could you share a little bit about Jabil's automation strategy and why it's critical for automotive quality?
Sure. First of all, I would say automation in the automotive industry is not new, but evolving significantly. Why it's so important for products like this that are safety critical devices is really centered around quality and its ability to scale. So if you think about today in the contract manufacturing world, handling is the #1 defect that we see. And so designing a line from the beginning, working with our partners like Aeva, ultimately we've been able to work together to ensure and design for automation and work through the industrialization and manufacturability of that product. And as we roll out automation, it allows for a zero defect culture or approach. Also, what drives automation is the fact that the technology is evolving. It's complex technology, and I won't say from an assembly piece as much because of the way this is designed, but the specifications and the tolerances are very tight. Therefore, precision and repeatability is required to be deployed as part of the automation strategy to, again, get the quality levels that are expected in the regulated environment.
Thanks. following on that thread on automotive quality, Vikas, could you touch on Tower's investments towards automotive quality?
Yes, thank you. So Tower has been working in automotive quality and standards for a very long time. We carve out our overall revenue into different areas, and automotive is about 10% of our total revenue. In all of our factories, automotive runs about 20 to 30%. In some factories, it's up to 40%. We have specific automotive standards and flows that we use for that. And in those, we use significantly heightened metrology as well as test capability within the supply chain to make sure that we adhere to the automotive standards. And we basically supply to automotive. One factory in Japan, for example, basically at some point used to drive 35% of the total automotive market in Japan, as an example. So we've been working with automotive for a very long time. We are well equipped to do it, and we are enthused in supporting Aeva in that dimension as well.
Excellent. So a hot topic in supply chain this year has been global trade. As both Jabil and Tower operate large global footprints, how do you think about managing those footprints, and how do you undertake to offer your customer a more resilient supply chain? Let's start with Chad.
Yeah, so first of all, I think a core strength of Jabil is the fact that we have 100 sites around the world. So we're positioned very well to deal with the trade situation that's going on. If you look at it from an automotive perspective, there's a lot of certification requirements. You've got IATF. If you look at the products we're supporting, functional safety, cybersecurity, cleanliness requirements. So we have a strategy to continue to expand certified sites amongst those 100 sites. Today, we operate in most of the core regions. We typically have 2, 3 operating sites to give versatility and localization opportunities for our customers. If you think about what's going on right now in the global trade scenario, we've built what's called a network optimization tool, which is really like a lowest landed cost tool. But what we've done to that is we've integrated the trade portion or the tariff activity, both inbound, outbound variations. So we can quickly simulate lowest landed cost in any of our factories for our customers. And as things move, as they do on a daily basis, I would say, we're able to just change that and reflect what the impact could be or would be. And so we do a lot of simulations with our customers to ensure that we're in the right spot today, and we're preparing for potential movement if that's required for the future. Regarding supply chain resilience, I think we kind of break that up into 3 categories. You know, we're constantly monitoring lead times, looking at supply levels, looking at end-of-life notifications, just to have a clear understanding and constant monitoring of the supply chain. At the same time, to build resilience and reduce vulnerability in that, we work with our partners to look at localization, look at dual sourcing activities, look at different supply arrangements for buffering and so forth. And lastly, digitalization, and working with our customers and our supply chains to be able to clearly communicate forecast and collaborate on forecast accuracies and so forth.
Super. Vikas?
So from our standpoint, we, as an exercise from very beginning, have multiple factories that we put our flows in. So the high performance flows, the type that you guys have as an example, we basically drive that into multiple factories so that risk mitigation, both from the point of view of volume increase, as well as capability to mitigate against disasters like earthquakes or wars or anything else, we drive it into multiple factories. We not just do it in multiple factories, we try to do it geographically variant areas, as well as even in a couple of ways in different continents. So from our standpoint, the silicon photonics that we supply to Aeva is significantly risk mitigated on all of those fronts.
Great. It's certainly a moving target, so I appreciate your insights. For our wrap-up question, I'd like each of you to share a little bit about our partnership Waqas, we've been partnering, you mentioned, for over 6 years on our silicon photonics roadmap. What is your view of how we've worked together over the years, and what are your plans to help scale the silicon photonics partnership for the future?
Yeah, so we appreciate Aeva as the leaders in LiDAR, and we have been working in silicon photonics area significantly on the datacom data center area, but right along with it, the LiDAR is an emerging market in multiple areas, as you heard all day long today. With Aeva, we've been working with for 6 years. We have now taking our flows and putting into 6 factories for silicon photonics. We are also increasing our test capability to make sure that the wafers that we make for Aeva are tested in the right manner. And so in multiple ways, we are ready for the scale, even improved scale that Aeva is going to experience hopefully in the future, and we can serve them from multiple manners, both from a manufacturing capability as well as test.
Excellent. Chad, the Jabil relationship is a little bit newer, going around 2 years, working on our Atlas project in automation. Our head of PD always tells me that their line is going to be very, very cool. So can you tell us about the line we're deploying this year and what's cool about it?
What's cool about it? Everything. So no, I think there's 3 different aspects. You touched on it a little bit in your presentation. There's traditional SMT, which is surface mount technology. I think what's different about what we do for you is the level of cleanliness requirements, and each step of the process has very specific cleanliness specifications that we follow. That product then moves into the back-end process, which is done in a clean room, and that is fully automated in a somewhat traditional manner for us. And then lastly, you touched on the test design. I think a couple cool things about it is not only the automation process, the simultaneous activity or testing that goes on, is the fact that we've designed that solution to be able to do short and long range testing all in one single footprint. And we do that by elevating the test platforms and actually shooting the laser over the manufacturing floor, for instance. But we're doing that all automated and touchless, and the goal again is quality.
Yes, that will definitely be very cool. Get our up in Q4 of this year. I want to thank you guys for joining us and sharing with everyone here about our partnership and some of your insights on how we're partnering to help us scale. So thank you.
Thank you.
Thank you.
Thank you, Susan, and good afternoon, everyone. My name is Saurabh Sinha. I'm the Chief Financial Officer of Aeva. I'm sure the series of presentations and discussions this afternoon has provided you a deeper understanding of our differentiated tech and the capabilities of our perception platform. I have been with Aeva for almost 5 years now, and it has never been busier and more exciting time for all of us as we embark on the next journey of commercial momentum. Let me provide you an update on how we are doing in the year, including a summary of our Q2 results, along with a framework of how we think about Aeva's longer-term opportunities. We just released our Q2 results, so let me dive into it right now. Our results keep us on track to deliver on our objectives for 2025. Revenue in Q2 was $5.5 million. This is a record quarterly revenue for Aeva and was driven by a combination of growing sensor shipments along with NRE from Daimler Truck and other customers. Non-GAAP operating loss for the quarter was $25.1 million, which is a 22% decline on a year-over-year basis. We continue to be disciplined in how we spend and reallocate certain R&D activities. This is consistent with our plan to reduce non-GAAP operating expenses by 10 to 20% on a full-year basis in 2025. Turning to gross cash use, which we define as operating cash flow less capital expenditure, it was $31.2 million for the quarter. We finished Q2 with a total available liquidity of $174.8 million. This consists of $49.8 million of cash, cash equivalents, and marketable securities, and $125 million in undrawn facility that is fully available to draw at our sole discretion. In addition, the previously announced LG Innotek equity investment of $32.5 million is not included yet in these liquidity numbers I mentioned. We have received the CFIUS approval now and expect the transaction to close very soon. This would further bolster our balance sheet and take the total liquidity to over $200 million. We continue to believe that our available liquidity and no debt positions Aeva to execute on our current programs and win new business. Looking at the rest of 2025, our strong results in the first half of this year puts us on a path to exceed the full year 2025 targets we set at the start of the year. We had targeted 2025 revenues to grow by 80 to 100% on a year-over-year basis. We now see full year 2025 revenues growing by 100 to 110%, while still reducing non-GAAP operating expenses by 10 to 20% on a full year basis. Now let's focus on longer term prospects. As Surush discussed earlier, our one unified perception platform enables Aeva to pursue a broad range of applications and collectively represents $80+ billion in market opportunity. And as you can see with the customers and partners in attendance today, our commercial momentum continues to build. In terms of revenue opportunity for Aeva, let me share a bit about two markets where we are furthest along in the initial phase of scaling. Let's start in automotive first. As you know, we have secured a major production program win with Daimler Truck, where Aeva has a significant content as a primary long-range sensor for autonomous program. We are also engaged on multiple other opportunities, such as with the global top 10 passenger car OEM and other engagements in trucking, mobility, and pass car. To give you a sense of what potential revenue could look like from one of these programs, a typical production program with a large OEM, whether it is trucking or pass car, can range between 150 to 200 million on an annual basis at scale. This means 2 or 3 production programs with large OEMs would represent an overall annual revenue opportunity for Aeva of 400 to 500 million at scale in automotive. And we expect to win more programs over time. In manufacturing automation, we can use the one-dimensional displacement sensor market as just one example of massive revenue opportunity for Aeva. This market is already an established and growing market from $4 billion to $6 billion by end of 2030. Capturing just a 5% market share would represent an annual revenue opportunity for Aeva of $300 million. Given we are already collaborating with leaders such as SICK AG, which alone has around 15% of the market, we believe this is achievable as we scale with them and additional partners that we are working with. So we expect to significantly grow our revenues in the coming years as we execute on these opportunities. And these are just 2 of the major markets we are seeing strong commercial traction in. As we progress to other large markets of consumer, robotics, defense, which together has a total TAM of $33 billion, even capturing a single-digit penetration of the TAM would result in Aeva's aggregate revenue opportunity at scale in the billions of dollars. Putting all this together, I would like to now provide a path of profitability framework for Aeva. With a growing commercial momentum, we target growing revenues on an annual basis at 100% growth rate, We have done it in the past and expect to continue to do for 25 and beyond. We expect that this foreseeable future, we scale and deploy with additional programs over time. At this time, we expect to maintain our strong discipline around operating expenses as well. This is something which we have delivered over the past few years. We remain on track to lower our non-GAAP operating expenses by 10 to 20% in the current year of 25. Beyond this, we will continue to be strategic in how we support our existing and new programs. To support commercial momentum, we target annual non-GAAP operating expenses to grow in the range of 5 to 15% per annum starting in 2026. From a gross margin perspective, Aeva, we believe we are similar in profile to a fabless semiconductor company. We have good visibility into our BOM and manufacturing costs as we ramp volumes. While the product mix, ASPs, and manufacturing efficiencies will eventually drive the exact gross margins, we believe we can be in the range of 35 to 45% at scale and reach 50% over the longer term. As I mentioned earlier during my presentation, Aeva has a meaningful liquidity position that we believe enables us to continue supporting our customers to SOP and win additional programs that we are engaged on. So to conclude my presentation, I'm incredibly excited for what is in store for us. We have a differentiated technology platform with a significant moat, and commercial demand for our solution is expanding well beyond just automotive and traditional use cases for LiDAR. As we begin to reach SOP for our initial programs, we are laser focused on execution. We have assembled a strong team at Aeva with significant experience scaling new technologies across multiple industries, including at automotive and technology companies. Together with our world-class partners, we believe that Aeva is positioned to deliver on this path to profitability, which I just described. And with that, let me invite Surush and Meena on the stage as we take the questions.
Conduct our question and answer session. If you have questions, please raise your hand. We'll have mics around, and I'll be moderating. Saurabh's here already, but Surush and Meena, the two co-founders, will be joining us as well. So we'll just take a second before.
Great.
George?
Hey guys, George Enriquez from Canaccord Genuity. I wanted to focus a little bit on manufacturing. The telecom industry has had a sort of a legendary issue with scaling silicon photonics, and now we're starting to hit an inflection point there. What exactly is the difference, if you can articulate for us, between scaling telecom-related silicon photonics and LiDAR silicon photonics, and how you expect to overcome any of those issues?
You want to talk about that?
Yeah. So in the telecom, of course, the biggest thing is the fact you transmit most of the data in fiber. So one of the most obvious pieces is that the silicon photonics interface is usually fiber, while in our case, we have to deal with free space. So we have to clean up the signal, the light a little bit, make sure it works in free space. But the fundamental silicon photonics inside is very, very similar to coherent telecommunication. It's the same coherent detection, same more or less detector mechanism. What really makes it different is on the laser side. So silicon photonics, you can argue, is more of a platform that we utilize that is very, very similar to the silicon photonics in telecommunication. But where it gets different is on the interface of the silicon photonics and the laser side, where our laser, we have to modulate it slightly different to get the distance, to get the velocity. Telecommunication, they do different, of course, to transmit data rather than chirping the wavelengths. But the fundamentals is the same when it comes to the silicon photonics. And we use the same processes like what Waqas have mentioned in Tower as well.
Suji over here. For sure.
Sure thing. Hey, great. Thanks, guys. So thanks for the presentation. So just appreciate, Saurabh, the scale, revenue opportunities for these customers. What's a realistic time frame for, say, Daimler out of the gate for it to reach that? And is it possible for another customer to be at that level at the same time? Or is that not the right expectation coming out of the gate?
Yeah, Suji, great question. So our customers are at different stages in their journey for SOP and beyond. We expect that a customer, after about 2 to 3 years going into SOP, will ramp and reach that state of scale. But it varies by customer and also by industry.
And just to add, I mean, as we have said, each segment we have multiple programs coming with SOPs, right? Daimler Truck is one. We talked about our SOPs next year. That will start ramping in 2027. And then, following that, sales will reach steady scale. Same thing, and we talked a little bit about on the passenger side, follow that. We expect that would follow by about a year or so offset after that. So that's already starts to get us that scale in automotive. I think that industrial things are moving faster, right? Since we announced we're, fully booked in terms of our capacity right now. We have, initial order of 1,000 units. We're working already with SICK and LMI, and so, that part of the business is very exciting for us. It's one that is very rapidly moving. And as you can see, the beauty there is it's working off the same unified perception platform that we talked about. So software-defined, leveraged economies of scale, and we expect that those actually hit ramp-up production earlier than the timelines of 27, 28. So in the next year or so, we are already going to expand capacity. And we're doing that ahead of this, install of capacity ahead of this demand. And we're not just doubling the capacity out of thin air. We're seeing the demand, and we're trying to respond to that over time.
Joe over there, third row.
I'm Joe Moore from Morgan Stanley. I wonder if you could talk about, as you think about SAM, the role of price. Can you, as you reduce price, do you get higher penetration in auto? Industrial, obviously a different price point. Can you talk about, how you think about that balance between, the profitability that you're looking to get and growing the market by bringing the price down?
Yeah, if I heard correctly, it's asking about the price points in different markets and how that applies across the different SAMs. So I think for us, obviously, as we stated, there is this misconception in sensing and LiDAR particularly that, okay, we started at tens of thousands of dollars, now you get to maybe about $1,000. You have a lot of competition also from Asia that is maybe low hundreds of dollars, but different performance, different technology. But I think hopefully what we were able to communicate today across applications of different markets, we're able to reduce this price down because of the fact that we use the same chip, use the same manufacturing processes, use the same partners, and that allows us to have then, basically multiplication factor effect of volumes, even though each of these market segments are different. At the same time, that allows us then to have different ASPs, different gross margin profiles, some of which, significantly higher than a typical LiDAR sensor even can achieve in the typical space. And that helps us to blend and balance that across the markets. I think that's I think a bit of a unique position for Aeva. Because of our attraction to these other markets across these different verticals we talked about, having used the same platform, we see a complete difference in variation in pricing. So we talked, okay, in automotive, with trucking starting with, over $1,000 ASP. Obviously, our costs are, significantly lower than that. In passenger, pricing is a little bit different, right? That's, of course, higher volumes, costs are slightly different there. But then in industrial automation, $4 billion market, going to $6 billion, in the manufacturing automation, those ASPs are in the thousands of dollars. So, and from a complexity of our BOM and the COGS, that allows us to have a varying ASPs because of the unique differentiation of technology that provides us this blending, if that answers your question.
Richard over there, fourth.
Thank you, Richard Shannon with Craig-Hallum. Soroush, maybe if you can talk a little bit about the pipeline, probably more interested in automotive than others, but if you want to go more broadly, that'd be helpful. Maybe you can talk about it in one particular way, which is you've talked about FMCW LiDAR being kind of the, potentially the natural end state for LiDAR, kind of like what we've seen with radar. So with that context, you haven't talked too much about the number of companies in your pipeline for automotive, and sort of get why, but maybe help us understand how broad that pipeline looks, and then maybe reasons why companies haven't started engaging with you or just not yet.
So first of all, I would say that across automotive space, within passenger and trucking space, as you saw, we even announced today, we are engaged with, to my understanding knowledge, across the OEMs that are having actual RFQ decisions coming up into production. We obviously tend not to talk about every single engagement because we don't think that's a meaningful indicator necessarily at the early stages. But when they become meaningful, we start talking about them. Even today, we announced a collaboration with Bendix. That's a complete new engagement that was not discussed in our pipelines before, right? So that doesn't mean that we're not engaged across OEMs and passenger, trucking, and others. We are absolutely engaged on multiple. If you look at our customer base, first of all, there's not so many OEMs with significant LiDAR deployments and models, and there's deployments there's consolidation within the brands. But I can say that across the OEM opportunities, where there is the right fit for technology for level 3+ automation in passenger and commercial vehicles, we are engaged in nearly every program. There always may be opportunities where it may not make sense for us, or an OEM says, look, I am going in SOP this year or early next year or something, and like they needed a sample that was earlier before we reach maturity, and those tend to be the case. At the same time, we have said, look, we're not going to win everything, but we are seeing very strong demand reaction from the market, as evidenced by some of the partners you saw today, the traction we have. So that's what I would say. I think as we bring the product to the market, first in trucking, then the passenger with its top 10 OEM, expand into ADAS for commercial vehicles, we believe all the other partners start to also, OEMs will start to follow. I think one of the reasons also we formed this strategic collaboration with LG Innotek is because of the synergies, level of expertise, and the relationships they already have in the automotive sector as well, where we may not be able to satisfy as a company every single opportunity that may come across our desk. So over time, we can leverage those relationships to also serve those other regions or markets or relationships that are naturally better fit with some of our partners. So that's our approach, within automotive. But I also want to add that obviously automotive is not our only sector, right? We have significant interest in these other markets that we're going to continue to get traction in. And unlike most others in the space that are either fully automotive or mostly fully industrial opportunities pursuers, we see opportunity across both of these, across multiple markets. And we are in a very good position in automotive. We believe we're going to get more wins, and we are well on track for those. We have talked about that. We expect some of those to complete in the next few months. And then we need to execute on the industrial and the manufacturing automation side and expand from there.
Great. I think we have time for maybe one more question, if there's any in the audience. If not, I will turn it back to Soroush for closing remarks.
Well, first of all, I just want to thank you. I know we ran a little bit longer today. I want to thank all of you again for joining us at our Investor Day today in New York City. Hopefully you came across with a good overview of the company, where we stand, our opportunities, our traction in the market. You heard directly from our customers, our partners, their support being here today with us. You heard from our team members, the deep bench that we have here. You hear often maybe from me, or Mina and Saurabh, but seeing that actually in action. We are really excited about the prospects that we have. We're excited about the execution that we are actually doing and continuing on our journey to bring this product to mass production across markets. So as I said, we see perception is arriving and Aeva is leading the way. So thank you for joining us, and with that, we'll see you next time.